Hello everyone and welcome back. We are about to start a new section in this course. It's all about components, the add component decorator, and Angular's change detection mechanism. So let's see what all we are going to cover as a part of this section. So we'll first start with the components and the add component decorator. Then we'll see how we can create Angular components. So we'll be using Angular CLI in order to do that. We'll also see how we can create this on StackBlitz. Then we'll have a look at the add component decorator metadata and what all are the properties that this metadata object has. And then we'll see how the component bindings work. So how the template and the component class interact with each other via different sorts of bindings. Then there are a few lifecycle hooks that the TypeScript class, which are Angular components, implement. So we'll have a look at all these lifecycle hooks as well. What are their significances and what are the use cases wherein we should use a specific lifecycle hook. Now, as we have already seen, an Angular application is a tree of components. So there is not just one component in an Angular application. There can be n number of different components. But there are times when component needs to interact with each other. So since it's a tree of components, one component which is a parent component might want to interact with its child component, or the child component might want to interact with its parent component, or there might be sibling components as well which might want to interact with each other. So there are different interaction techniques for components in Angular, and we'll have a look at some of them in this section. Then we'll have a look at the view queries. So we'll see how view queries work and how we can have an instance or a JavaScript representation of a template variable in the TypeScript class and how we can use it in order to change the properties and attributes on that HTML element. And we'll conclude this section with Angular's change detection mechanism. So there's quite a lot to cover. Let's start this section by having a look at components and the add component decorator. So I'll see you guys in the next one. Alright, so what exactly are components? Well, there are several analogies that can be given as to what components are and what is the role that they play in an Angular application. But just for the sake of this conversation, just consider them as Lego blocks just in code. So this might look familiar, right? This is some sort of a diagram that we saw in the first section of this course, wherein I told you guys that an Angular application is a tree of components. So it would start with a root component, which is the app component in this case, and then it would branch out to several other components, thereby creating a hierarchy that looks something like this. So what exactly are Angular components? Well, they are the most basic building blocks of UI that we have in an Angular application that we have already seen is a tree of components. So whatever you have on an Angular component is visible to the user as the user interface. And this user interface would mainly be a template of the component. Angular components are subsets of directives, and we'll see what directives are in a later section of this course. But there are basically three types of directives. We have structural directives, attribute directives, and component directives. So the main differentiating factor between these would be that a component directive has template, while a structural directive and an attribute directive doesn't have template. Another peculiar thing about components is that we can only instantiate one component for a specific element. So you can think of components as custom HTML elements that you create. Whatever element that you have, whatever that HTML element that you create can only instantiate one component at a time. Now, in order to create a component, we use a TypeScript class and we decorate that TypeScript class with the add component decorator. And this add component decorator also accepts a metadata object. This metadata object would then determine what is that component all about, how is it going to be processed, how it's going to be instantiated, and then used at the runtime. Now, we have already seen this in the module section, but in order to register a component on a specific Angular module and then use that component inside that Angular module, we need to add the component to the declarations array of that Angular module. Finally, Angular components also implement various lifecycle hooks, and that's how they control their runtime behavior. We are going to see what lifecycle hooks are in one of the later sections of this course. So let's quickly see what a component looks like. This is the app component, and it's a pure TypeScript class. It's decorated with the add component decorator. And inside this add component decorator, we have also passed in a metadata object. This metadata object will have some properties that we are going to have a look at in one of the later videos in this section. But it basically determines how the Angular component is going to be used, what is the template that it is going to use, and things of that sort. Now, as you can see, we have a template URL here, which points to some HTML file, which is this right here. Now it has quite a lot of code, so for the sake of simplicity, let me just clear it down to just one H1 that says hello world. Alright, and now we have used this app component inside the index.html file that we have right here. So the app root tag that we are using right here corresponds to this app components selector that we have here. So by doing this, we are telling the Angular application that if we use this particular HTML tag like the way we have done here, then it needs to inject the template that we have mentioned right here, which would eventually correspond to this HTML file. So we are telling Angular that it has to inject this template in the opening and closing tag of this component right here. Now the app is already running, as you can see here. So let me just go to the browser and see what this application looks like. As you can see, we are seeing the hello world being printed onto the screen. And if we have a look at the element right here, we are seeing the app root HTML tag, inside which we see an H1 that says hello world. And this is the same H1 that we defined right here inside the app component template. So this is all there is to actually know about an Angular component and what it is all about. But then there are several other parts of it. Just to recap, in this video we have seen what Angular components are. They are the basic building blocks of UI in an Angular application. They are a subset of directives, and they are plain old TypeScript classes that are decorated by the add component decorator, which has a metadata object that we will be talking about in one of the next videos. And we need to register components onto a module in order to use them. And finally, they also implement some sorts of runtime behaviors that we'll be having a look at once we understand the lifecycle hooks in an Angular component. So in the next video, let's start by creating a component on our own. So I'll see you guys in the next one. So let's quickly see how we can create Angular components using Angular CLI in VS Code. So in order to create an Angular component, we will use the Angular CLI and the generate command of it. We'll supply the type as component. So ng space g, that stands for generate, space c, that stands for component, and then we'll supply the name of the component. It will create a folder named the name that we have specified, and inside that folder it's going to generate 4 files. One would be the styling sheet file that can either be in CSS or in SCSS or in any other style format like Sass or less. Then it is going to generate a template file, which would be an HTML file, a spec.ts file, which is going to be the unit test case file for our Angular component TypeScript class, and then a TypeScript class for our Angular component. It is also going to show us a message that looks something like this, wherein it will say that 4 files have been created and 1 file has been updated. This updated file would be a module wherein this component that was recently created would be registered by it being added to the declarations array. So let's quickly see how we can create components in Visual Studio Code. So I'm going to use the ng generate command, ng-gc, and I like to create all the components inside a folder named components. So components, and let's say that I wanted to create a chat component. So it created 4 files for me, and it updated an app module because that's where it by default registers this generated component onto. So if I have a look at the app folder, there's a components folder inside which there's a chat folder wherein we have all these 4 files created for us. And then it also has updated the app module. There's this chat component that was added to the declarations array right here. Alright, now that I've added this and registered the chat component as well, I can use that inside my Angular app. So in order to use the chat component, I'll use its selector, which is this. So app-chat. So if I copy this and paste it over here like this and save this, it's going to use the chat component HTML, which is the template for the chat component, and render it onto the UI along with the app component template that also has an h1 tag that says hello world. So if I change this template to, let's say this is the template of the chat component like this. If I go back to the application, it's going to say hello world, and this is the template for the chat component. Now it has the app root component inside which there is this template for the root component. Along with that, there is a tag named app-chat, which is also containing the template for the chat component. And this is some sort of a hierarchy that it has created. The app-root is the root component and the app-chat is the child component here. So this is a hierarchy, this is the parent and this is the child. Now we can also have sibling components here in Angular. So let's say that I wanted to create a sibling component and call it users. This is going to again do the exact same thing. It's going to generate 4 files and update the app module. And it registered the users component onto the declarations array, as we can see right here. And now that I have registered the users component onto the app module, I will be able to use the users component inside the components folder, inside the app component HTML, just like we used the app chat. Let me also update the template. So let's say this is the template for the users component. So if I save this and go back to the application, I should see 2 paragraphs saying all of that. Now the chat component and the users component are siblings of each other, as we can see here in the hierarchy in the elements section. I can also create a child component for the users component. Let me call that user. And what I'd like to do now is, because I'm creating some sort of a hierarchy, I would like to create the user component inside the users folder. So I'll say users/user. It will generate a user folder inside the users folder, as we can see right here. And it's going to generate 4 files in there. And then it would have also updated the app module. So if I see that, there is this user component and it was registered on to the declarations array right here. If I save this, it's going to auto indent that so that the code is more readable. Alright, now let's say that I wanted to use the user component inside the users component. So I'll go to the template of the users component. So just like we have the app-users, we will also have a selector called app-user. Angular CLI by default generates selectors in this order. So it uses the name of the component that we have specified and appends an app hyphen before it like this. So I will be now able to use the user component inside the users component, which we are doing right now. So if I go back to the application, I should see user works, which is the by default text for a template that was generated by the Angular CLI. So if I open the users component, I see a paragraph that we have right here. And then right below that, I also have a user component that has another paragraph that says user works. Now let's quickly see how we can generate the exact same thing in StackBlitz. I already have it opened right in front of me. I can simply right click on this, go to Angular generator and click on component and create the chat component, and I'll do the exact same thing for the users component. And inside the users component, I'll right click and again do the exact same thing and generate a user component. So it has generated all those components for me. It will also add those components to the module file. Here all these components have been imported and added to the declarations array like this. So now if I go to the app component and I try to use app-chat and app-users, and save this. And inside the app-users, if I go and use the app-user and save this, I should be able to see the exact same things in here on the generated Angular application. Now, for a specific component, we can see that it's a plain old TypeScript class. We have the user component TypeScript class. It is decorated with the add component decorator, which accepts a metadata object that we have right here. And it has this metadata object that contains a few properties like selector, template URL, style URLs, and there are several others that can be added here. Now all these properties are used to configure this Angular component and tell Angular how it needs to instantiate this component and what can be used in order to render it. And then there are several other things of this sort, which is something that's the title of the next video. So we are going to talk about the Angular component decorator metadata in the next one. Alright, so in the last video we saw what this component decorator is and what is the metadata all about. Let's quickly now examine what all are the properties that this metadata object has. So the first property is selector, and this is the CSS selector that actually identifies this component onto the template. So we see this component decorator, and here's the selector property. The selector property right now corresponds to app-root, and this is the exact same tag that we have used inside the template, which is the index.html. Instead of app-root, let's say we change it to app component and save this. Now if I go back to the application, it will say that the selector root-component does not match any elements. And that's because we are using the root-component selector here, but then we are using app-root here inside the index.html. So if I replace this with root-component and save this and go back to the application, I will see that the app would run as expected now. The second thing is the template. And we also have a template URL. So right now in the app component TS, we have template URL, but there might be chances wherein you don't really have a very large template. So creating a new HTML file just for the template is not really going to make much sense. So instead of doing that, you can simply use a template property as well. And to this template property, you can add some template, like say I add this markup that has an h1 tag. So if I save this now and go back to the app, I should see that markup being printed onto the screen. This markup can also be multi-line. So right now I'm using double quotes. So to make it multi-line, we'll have to use template literals or the backticks syntax. So we have seen the backtick syntax already in section 2 of this course. So if you haven't really watched that video, I'd highly recommend you to watch that first. So now that we are using the backtick syntax, I can make this multi-line as well. So let's say that I also create a paragraph tag here that says this is a para. And if I save this now, it should work as expected. But since we have a large template, let's just stick with the template URL. Next up, we have styles and style URLs. So right now we are using style URLs, and style URLs correspond to the files that has all the styles that you want to apply for your Angular template for the component. So right now our styles are present inside app.component.scss, but apart from style URLs, you can also use the styles property, which is also an array. And then in here as well, you can write multi-line strings by using the backticks syntax. And in the template, which we have right here, let's say that apart from this h1 tag, there was also a paragraph tag. And let's save this. Now inside the app component SCSS, which we have here, let's say that for the h1 tag, I want to apply a color of red. And in here in the styles, I'll apply the same property for a paragraph. So I want this color to be blue. And let me save this and go back to the application. So I should see that the h1 tag is in red color now and the paragraph tag is in blue. And since this is an array, you can also add other styles to the styles as well as the style URLs property. So let's say that I wanted to add another SCSS file here. So I can simply create that file. And now that we have this SCSS file created, we would, let's say, make the background color of the h1 tag to green maybe. and let me save this and go back to the app. So I should see green color for the background, red color for the foreground, as well as the blue color for this paragraph tag. All of this coming in from different SCSS files as well as the styles property right here. Next up we have the providers array. Now this providers array is the exact same thing as we have it on the ng module decorators metadata object. So if I go back to the app here, inside the app component, I can also add a providers array. And let's say that I wanted to register some service onto it. Let's say data service. Now what's going to happen is this providers array is going to tell the injector of this component to create a new instance of the data service and not use the existing instance of the data service that was provided by the injector of the app module or the module that this component was registered on. Now I'm pretty sure that that's a lot to grasp in just one video. And that's why you'll be able to better understand this whole concept once we have a look at the hierarchical dependency injection concept, which will be coming in one of the later sections of this course. But just for the sake of knowing it, just keep this in mind that making a providers array and using a service inside the providers array on a component would create a separate instance for this particular service for this component as well as its children. Then we have the animations. So we can list a few animations for a specific component in order to use them inside the component. Now in order to use animations in your Angular application, we'll have to use the browser animations module. So we import the browser animations module from angular/platform browser/animations first, and then we add it to the imports array right here, which gives us the ability to then use some of the methods that we can import from the Angular animations module inside our component. So we've imported a few helpers like trigger, state, style, and several others. And then we are using them inside the animations array right here. So we trigger the open close animation. There is this state which is open with a style of this. Then there is another state which is closed with a style of this. And then we have the transition from open to closed, which needs to animate for 1 second. And then there is another transition from closed to open, which should animate for around 0.5 seconds. This is all there is to it. And in order to trigger this inside the template, we use this animation name like this. And then there is also a state which is attached to it. So if this is open, then we need to run the open close animation in the open mode. And if the is open property is set to false, then we run it on the closed mode. So if we go back to the application, here's this animation and how it looks like. So if I click on this, its state changes and that happens in an animated fashion. If I click this again, it resets to its original state and again and again. Now animations are a vast topic in themselves. So just covering animations in a small video in this section isn't really going to cut it. So I'll probably create another section for Angular animations and we will dive a lot deeper into Angular animations in that section. Next up we have the encapsulation, which determines the view encapsulation state for a particular component and what is the strategy that it has to use. And then finally we have the change detection strategy. Now view encapsulation is again a topic in itself, so we are going to cover that as a part of the next video. And the change detection strategy is something that will make more sense once you actually understand how Angular runs change detection in order to synchronize the model and the view. And that brings us to the end of this video. In the next video, let's continue our discussion on view encapsulation. So I'll see you guys in the next one. Now in the last video, we saw a few metadata properties that we can configure our Angular component with. It's time for us to now have a look at view encapsulation. So before that, let me first create some properties and CSS classes. So I'll start with a styled CSS class. And this is going to have a border of, let's say, 4 pixels, dashed black. And I'll save this. Now inside the app component, I'm going to wrap everything that we have with a div, and I'm going to apply a class of styled on it. And let me just wrap all the content inside this div. Now inside the user component, let's create a similar class and call it styled. And in here, Let's change the background color to Indian red and save it. And inside the user component, let's wrap everything inside a div with a class of styled and wrap the rest of the markup with this div. Alright, now the first type of view encapsulation that we have in Angular is emulated, and this is the default view encapsulation strategy for styles in Angular components. What this would mean is we will be able to inherit global styles, but local styles are going to be private in nature. Now, since this is by default the encapsulation strategy, we don't really have to do anything as such in order to make this work. This is how it's going to look like right now. So we did say that we want to wrap the app component with the div and a class of styled on it. This styled makes a border of 4 pixels of black color in a dashed fashion. And then inside the user component, I also wrapped the whole markup with a div with a class of styled. And this styled sets the background color to Indian red. So what this would mean in the emulated mode is that the user component is going to have a background color of Indian red, but it is also going to have a black dashed outline or border of 4 pixels. But the other parts of the app component are not really going to have the Indian red as background color. So if I go back to the application and see, we can clearly see that the whole view is covered with a black border of 4 pixels, and our user component as well is covered with a black border of 4 pixels. But the Indian red color that we have on the user component didn't really leak to the outside world. And this is by default the strategy that we have for styles in Angular components. Now, in order to implement that, Angular uses some sorts of attributes like the ones that we have here that says ng content yrm c21 and something like that. So if you click on this div and have a look at the styled CSS, it is also appended with a ng content yrm c22 attribute, and that's how this particular style is only being limited to this particular component and it's not leaking outside because the exact same attribute is not really present outside. The number is a bit different here. So this has C19 everywhere. Then we have C21 here, and C22 is the only number that we have on this attribute inside the user component. And that's how Angular is able to implement this shadow DOM, and that's how the local styles of the user component are not leaking outside of the user component. The other strategy for view encapsulation is native, but it has been deprecated in favor of shadow DOM. Now shadow DOM is used to encapsulate styles, so global styles will not be inherited inside a component and local styles from a component will not really leak outside of the component. This is especially useful when it comes to creating widgets, when you don't really want your widget styles to leak outside so that they affect the overall application, and you also don't really want the overall application global styles to interfere with the styles that you have implemented for your own widget. So in those cases, you would generally use shadow DOM. So in order to use shadow DOM as the view encapsulation strategy, you can set the encapsulation property to view encapsulation. Now view encapsulation is an enum that you have to import from angular/core like this, and then we can set it to shadow DOM. If you have a look at the autocomplete, it also says that native has been deprecated since 6.1.0 in favor of shadow DOM. We'll use shadow DOM here. So using the shadow DOM as the view encapsulation strategy will make the user component to lose the black border. And if we go back to the application, that's what we can see right here. So the global styles are not really leaking inside the component, and that's why we have lost the black border around the user component. But we can also see that the styles from the user component are not really leaking outside that. And let's also inspect the elements that we have here. So for each and every element, like the user component, we'll see a shadow root element that is added by Angular. And this has the styles that we have for that particular component. Something like this. All right. The last thing is view encapsulation.none. What this is going to do is it's not really going to make anything encapsulated. So all the global styles would be inherited inside a particular component, and the component styles as well would leak outside of this component and would be used as some sorts of global styles. So what this would mean is that the user component is now going to have a black border, and the other components outside of the user component would also have a background color of Indian red. So if I go back to the application, we can clearly see that this is the user component which has the black border now, and the Indian red color has been leaked outside of the user component that was only restricted till this black border here. And that brings us to the end of this video. We have seen 4 types of view encapsulation strategies in Angular. So if you have a look at the yellow color here, just consider them as global styles and just consider the black color as local styles. So in this particular case of emulated view encapsulation, what would happen is that the global styles would leak inside the local styles. So all the global styles would be inherited inside your component, but your component styles would stay private and they won't leak outside. In case of Shadow DOM, there's a very strict distinction between the local styles and the global styles. So both of them would never interfere with each other. Your global styles would not be inherited inside your component, and your component's style would not be leaking outside of it. And you would generally use Shadow DOM as the view encapsulation strategy when it comes to building widgets that you don't really want the styles of to interfere with some other applications. And Shadow DOM is also a replacement for native that we have already seen. Native was deprecated in favor of Shadow DOM. Finally, we also saw none as the view encapsulation strategy, wherein there won't be any strict separation between the global styles and the local styles. So the styles of your component are going to leak outside to the global styles, and your component is also going to inherit global styles. That brings us to the end of this video. In the next video, we are going to continue about Angular components and how we can use bindings in Angular components. So I'll see you guys in the next one. Now in the Angular components, there is a template and then there is a TypeScript class. So there are ways in which the template and the TypeScript class communicate with each other. And these are the bindings that they use in order to communicate with each other. So in this video, we are going to talk about those bindings. So these are a few bindings that are used by templates and TypeScript classes in order to communicate with each other in Angular components. So we have the string interpolation syntax, the property binding syntax, the event binding syntax, and the two-way data binding syntax. Apart from that, we also have class binding, attribute binding, and style binding. Now covering all of these in just one video won't really do justice to it. So over the course of the next few videos, we are going to cover all these types of component bindings in Angular. So let's first start with string interpolation. In case of string interpolation, we use these curly braces. Now properties and expressions are wrapped with these double curly braces. They first allow Angular to evaluate the expression and then convert it into a string that can then be rendered onto the DOM. The usage might look something like this, wherein we might have some property on the class that is wrapped in double curly braces, or we have some on the fly text that was generated and then we wrap it inside double curly braces. We can also call a method that returns a string, and then Angular calls toString on the return value in order to render it onto the DOM. So let's quickly see some code in order to understand string interpolation syntax. So for the sake of doing this, I'm going to generate a component, and let's generate a component inside the components folder. I'll create another folder and call it bindings, and inside that I'll create a string interpolation component. So Angular CLI will now generate the string interpolation component, and it will also register it onto the app module by adding it to the declarations array. Alright, so now that the string interpolation component has been created by Angular CLI, let's open that up. So there is this component class and then there is this template. So let's first start by creating a property here. Let me call this property message and assign it a value of string. This is some random message. Now, in order to use it inside the component template, inside the paragraph, I can use these double curly braces and I can paste the property name here and save this. Now let's quickly add this to the app component so that we can see what this looks like. So I'm going to go to the app component and let's comment all of this out and paste the tag for the app string interpolation, and let's see this in action. So I'll see this is some random message being printed onto the screen. Alright, so far so good. Now apart from this, there is another way of doing this. So a paragraph has an inner text property onto it. To this inner text as well, we can assign the message property, and here as well we are using the string interpolation syntax as the value of an attribute, which is inner text in this case. If I save this now and go back to the application, I should see two strings being printed. This one is using the normal string interpolation, and here we are interpolating the string onto a property of a paragraph tag. Now doing this is going to override the string interpolation that we might have inside these paragraph tags. So let's say that I had another message here, and then this takes an expression as well. So this is an expression wherein we have some message and then we have some string that we are going to add onto it. So I added a text saying this is going to be overridden, but then I also have the inner text property assigned with the string interpolation syntax here, which is reading the message property. So if I save this now and go back to the application, I would still see this is some random message. But if I remove the inner text from here and save this, then I'm going to get that value which was evaluated from that expression. So let me just let it be right here. And this is that overriding syntax that we had. Now apart from that, we can also assign some value to it on the fly. So I can add another paragraph here, and inside that I can add a string on the fly that says this is a string that was assigned on the fly. So if I save this and go back to the application, I should also see that being printed onto the screen. Apart from that, this can also contain some value that was returned from a method call. So let's say that I wanted to call some method in here. And let's say that this method name is getMessage. Now I don't really have this method right now, so I'm going to create that, and let me just simply return this dot message here, and I'm calling the getMessage method inside the string interpolation syntax right here. So if I save this and go back to the app, it should show me this saying this is some random message. But if we log something to the console here, we will also see that this method gets called every time. So it was called around 3 times here. That's why we are seeing this method was called text. Calling a method inside the string interpolation syntax is going to get that method called every time Angular performs change detection. Now we will be seeing how Angular performs change detection, but it is something that happens quite frequently in Angular applications, and whenever that happens, Angular is also going to call this method that was wrapped inside a data binding syntax, which in this case here is a string interpolation syntax. So this is going to cost us a lot of performance. So ideally we should not really call a method inside one of the data binding syntaxes, which in this case is a string interpolation syntax. Now let's discuss the other data binding syntaxes in the next series of videos. Just to recap, in this video we have seen how the string interpolation syntax works. So we can normally interpolate a string like this, wherein we use double curly braces and then supply a name of a property. Apart from a property name that we have on the class right here, we can also have an expression. So this is an expression that we have. We can also use it as a value of an attribute. So here we are using the inner text attribute, and then we are assigning the string interpolation syntax to it. Now doing this along with a string interpolation syntax in between the opening and closing tags of the paragraph tag is going to override whatever we have inside here with whatever we have in here. And that's what we have seen. Apart from that, we can also supply a value on the fly to the string interpolation syntax as we have done here. And finally, we also have a method called write inside the string interpolation syntax. But this particular syntax is going to cost us a lot of performance because every time Angular performs change detection, this method is going to get called. Now you will find all the syntax that we talked about in this video in this sample stack blitz. So you can just click on this link right here and you will be navigated to the sample stack blitz with the whole code that we just discussed about in this video. In the next video, we are going to talk about the property binding syntax. So I'll see you guys in the next one. Alright, so next up we have property binding syntax. Now anything that we have inside these square brackets right here represent the name of a property, and then we can assign a value to it using these double quotes. Now these double quotes can have anything ranging from a name of a property to an expression that resolves to a value, to a method that returns a value, or to a value that is generated on the fly. Now just like the direction of flow of data in case of string interpolation syntax, the direction of flow of data in the property binding syntax also goes from the TypeScript class to the HTML file. Let's now quickly see some property binding syntax in action. So for the sake of saving some time, I've already created a property binding component here. This is what the component looks like. I've already added a message onto it and a method that returns the message. I've also logged something to the console so that we can see this method getting called. And I've already added the tag for the property binding component inside my app component so that I can see that properly. Okay, so let's say that we have a paragraph tag here. Now this paragraph tag will have an inner text property onto it. So I can use the square brackets, and as soon as I place my cursor in between these opening and closing square brackets and press Ctrl space, I get a list of all the properties that this particular paragraph tag might have. So there is an inner text property onto it. I can assign it a value of message, and this message is the property that we have on the component class right here. So now if I save this and go back to the app, I should see bound via property binding being printed onto the screen. Similarly, we can also have an input, and input also has a value property. To this value property as well, we can assign the message property that we have on the component class. And if I save this, we should see an input field with the value of bound via property binding. Now, as I said, apart from properties that we have on the TypeScript class, we can also have an expression here or a value on the fly. So let's first see a value on the fly. If I save this, it should say this is a value on the fly. And just to prove that this can also be an expression, let's also place a plus sign over here and then add another string to it. This is another string, and save this, and we should see both of them getting printed onto the screen after concatenation. So here we are using an expression in order to assign the inner text property with the value that was resolved from this expression. Finally, we can also have a method as a value. So inner text can also be assigned a method call. So this is the get method call wherein we are returning this dot message. So if I go back to the app, I should see this getting printed, but I should also see some text being printed onto the console saying this got logged, which is coming in from the method that we have here. And as you can see, it's getting printed 4 times. So as of now, the method has been called 4 times, and that's because Angular ran change detection 4 times. Now again, we'll be seeing what change detection is all about and how Angular runs change detection. But then this is definitely something that we should be avoiding because we don't really want a method to be called again and again when Angular runs change detection. So we should avoid this in order to save some performance for our Angular application. And these are the different ways in which we can use the property binding syntax in Angular components. Next up, we are going to talk about event binding syntax in Angular components. So I'll see you guys in the next one. Alright, so this is the third video in the series of videos on component bindings. In the first two videos, we talked about the string interpolation syntax and the property binding syntax. In this video, we are going to talk about the event binding syntax. Now, event binding syntax is generally used when you want to handle some sort of an event that was generated on the DOM, either via some user action or via some sort of an action that was performed in the background, like a network API call or something like that. Now, in order to use the event binding syntax, in the parenthesis, you specify the name of the event that you want to handle, and then you assign it a value of a method or an expression. So this is how the syntax would look like. Here is the event name that you will use, and here's the expression or the method name that you will be supplying. Now, this method name can also be called with arguments, and we'll also see that in action. So let's quickly go back to Visual Studio Code and let's see some code in action. Now, for the sake of this tutorial, to save some time, I've already created a component named event binding, and I've already added it to the app component HTML here. So let's quickly see what we have in that component. Here's the template of that component. We have a button. After that, we have a horizontal rule. Then we have an h2. Here we are using the string interpolation syntax to render a property value that we have on the component here. Then we have another button, another HR, and then we have another input. And this is how the UI looks like at this point. But if we click on these buttons, nothing seems to work as such. And if we type something here, then we might want to target a specific use case in terms of inputs. So let's quickly see how we can make these buttons to work, and then also we can listen to the events that we have on this input. So for the first button that we have, I wanted to listen to the click event. So I'll use the parenthesis like this, and in between these parentheses, I'm going to supply the name of the event that I want to listen to. So this is the click event that I wanted to listen to. If you just place your cursor in between the opening and the closing parenthesis and just press Control space, then you'll have a look at all the list of events that you can listen to. So in this case, we just wanted to listen to the click event. So I'll specify that. And now whenever the user clicks on this button, the click event will get fired. So in order to handle that, I wanted to call a method, let's say on click. Now this method is not really present at this point on the component class. So I'll just add that here, and let's just alert that button was clicked and save. Now if I go back to the application and I click on this button, I'll see an alert popping up saying that the button was clicked. So now we are listening to the click event on this button, and when the click event gets fired, we are calling the onClick method in order to handle that. In a more practical use case, you'll probably have a form and then some buttons on it. So once you click on that button, you might want to submit that form and send an API call to some sort of a REST API with that form data so that you could submit the form for the user. Now, there might also be cases wherein you don't really want to execute a hell lot of logic. So creating a function for that specific use case wouldn't really make much sense. So apart from calling a function as a handler to the event, you can also run an expression. So let's say that on the click of this button that we have here, I wanted to change the animal value to something else. So I can run an expression here where I'll assign to the animal property that we have on the component class right here. I'll assign it a value of, let's say, the cat emoji, right? So now the animal property is going to change. So we'll also be able to see that change onto the UI because we are binding to the animal property via the string interpolation syntax right here. So if I save this and if I click on this button, I'll see that the emoji was changed from a kangaroo to the cat. So here we are running an expression wherein we are assigning the animal property a new value right on the template. So this is again something that can be possible when you want to handle a click event or any specific event on the DOM. Now let's say that you had an input that we have right here, and now you wanted to alert something whenever the user pressed the enter key. So for that specific use case, you can listen to the key up event and then run a method to handle the key up event. So on key up. So we are going to run the on key up method, and let's define that like this. Now the event that gets fired here can also be referenced with a unique keyword, and that unique keyword is the $event keyword. So whatever event gets fired here can be accessed via a specific event. So we can get access to the event object which got fired here using the $event specifier. Now since I've passed this, I can read this here. So key up event, let's say. And now let's first quickly log the key up event to the console. And let me just type something in here. So as soon as I start typing in, we see that the key up event gets fired, and we see an object here that is the event object that we got using the $event keyword here. And this has a few properties on it, like the key and the key code, as well as the code. Now if we try to use some other property name apart from $event, like let's say just EV, and save this, it's not really going to get us that event object. So if I try something out here by typing some text in the input, I'll just see undefined here. So again, this is a very important point to note, that it would only work and we will only have access to the DOM event if we use the $event keyword. Okay, so if I save this now and go back to the application, I should see the key up event being fired again, and that's what we are seeing here. Now let's say that on the enter key, I wanted to alert something. So let's first press enter, and on enter I get this keyboard event, the code for which is enter here. So I can use that right here, and I can do something like key up event dot code, and we have seen that if this is equal to enter, then we can alert something like enter was pressed. Let's save this. Now let me just type something in here, and now as soon as I press enter, you'll see that we get an alert, right? So these are the few different ways in which we can handle events. So again, just to summarize, we can specify the name of the event that we want to bind to, and then when that event gets fired, we can run a method or an expression in order to handle that event. And if we also want to have access to the event object, then we can use the $event keyword in order to have access to it. And then we can call a method on our component like this. Now one important point to note here is that the direction of this data binding flows from the template or HTML file to the TypeScript class, and that's what we have already seen. So unlike the string interpolation syntax and the property binding syntax, where the direction of data flow is from the TypeScript class to the HTML file, in case of event binding syntax, the direction of data flow is from the HTML file to the TypeScript class. Next up, we'll be talking about the two-way data binding syntax, but before that, we will be discussing about the input and output properties on components. So I'll see you guys in the next video where we'll be talking about the input and output properties. In the last three videos, we were talking about the component bindings, and we discussed about three types of component bindings, that is the string interpolation syntax, the property binding syntax, and the event binding syntax. Now we wanted to talk about the two-way data binding syntax, but in order to do that, we need to understand a very important concept in Angular, that is the input and output properties on a component. And input and output properties are also used in order for components to interact with each other, especially if they are in a parent and child hierarchy. So before understanding the two-way data binding syntax, let's first try and understand the input and output properties and how they can be used in order to set up a communication channel between a parent and a child component. So first up, we'll talk about the input decorator. It only applies to the parent and child relationship in components. And if we want data to be sent from a parent to child, then only we use an input property. The child decorates a public property on it with the input decorator, and then we pass the value to this property from the parent component template using the property name via the property binding syntax that we have already seen. So let's quickly switch to Visual Studio Code and see how this works in action. Now for the sake of saving some time, I've already created a hello component here. This is what the hello component looks like. So it has again a template, an SCSS file, a TypeScript class file, and a test case file. Now the Angular CLI has already updated the app module with the hello component, and in the app component template we already have added the tag for the hello component right here. Now let's say that the purpose of this hello component was to greet a user with some sort of a message, but then the name of the user was something that needed to be passed from the parent. So in this case, the app component is the parent component and the hello component is the child component. So here's the template for hello component. Here we say hello works at this moment, but then instead of works, we are going to say the name of the input property that we get. And this input property is something that we are going to get from the parent component template right here. So the syntax would look something like this, wherein we will have a name property on the hello component, and then we will pass the name property that we have on the app component. Now I already have a title property here, so I can simply use the title property as the value of the name property that we will be passing to the hello component. So I can simply specify title here. And now since this is a property that we are binding to, it's probably better to use the property binding syntax. So I can use the property binding syntax. Again, just to recall, the property binding syntax is a syntax wherein we wrap the property name with square brackets, opening and closing, and then we supply a name of the property whose value we want to pass as a value to the name property. So let us save this, and the app is already running here. So let's go to the application and see what this looks like. Now I'm seeing an error at this point, and it says that cannot bind to name since it isn't a known property of app hello. So I guess we haven't really specified a name property on the hello component, and that's exactly the case. So let's specify a name property here, and as we can tell from the app component, the value is a string. So we can expect the name property here to be a string, and let's save this. And now since we will be getting the name property here, I can essentially use that inside the template by using the string interpolation syntax, which is double curly braces opening and closing, in between which we will be specifying the name of the property, which is name here in this case. Let's save this and go back to the application, and we still see the exact same error message here. Now we already have a property on the child component. It's just that Angular is not aware of this property in the first place, and Angular is not really able to recall any such property on the child component that we might have. So in order for Angular to recall the name as a specific property that can be bound to from the parent, we will have to decorate the name property with something, and that something is the input property decorator. Now input is something that we import from Angular core as we have done here. And now that I have decorated the name property with the input decorator, this will tell Angular that okay, the hello component is going to have a name property that could be passed a value to from the parent. And that's exactly what we are doing right here. So if I save this now and go back to the application, I should see hello Angular being printed onto the screen. Now Angular is again the value of the title property that we have on the app component class right here. Let's say that I wanted to change this to Angular 9 and save. So the greeting here as well is going to change, and this name that we get is from the parent component that we are passing to the child component right here. Now since the name property is essentially a string, we can pass it via the string interpolation syntax like this, wherein we won't really be using the property binding syntax anymore, and we will simply be using the string interpolation syntax and interpolating the title property like this. So if I save this and go back to the application, I should see two greetings being printed onto the screen with the exact same message. And if I change the value back again to Angular and save, I should now see hello Angular being printed onto the screen in both these cases. Now one thing to note down here is that this is only going to work if the name property here is a primitive type, which would be a boolean, a number, or a string. But then if the name property is a complex data type like an object or an array, then we will have to use this property binding syntax only, otherwise it's not going to work. Because the string interpolation syntax, like we have discussed already, converts whatever we have inside here into a string by calling the toString method on it. Now we saw input property as a way to pass data between parent and child components, but from parent to child. Now what if we wanted to pass some data from child to parent? Well, for that we have the output property. And this again applies just to the parent-child relationship between components. So we must have a parent and a child in order for this to work. And this would only work in case we wanted to pass some data from a child to parent. Now in this case, what will happen is that the child is going to decorate a public property on it with the output decorator. And then the value of this output decorator is generally going to be an instance of type event emitter. Now whenever the child wants to pass some data to the parent component, the child is going to call the emit method on this event emitter, and then it will pass the data that it wants to pass to it. And inside the parent component template, we will be listening for that event using the event binding syntax that we have seen in the previous video. So let's quickly see how this works in action in VS Code. So again, for the sake of saving some time, I've already created the counter actions component, and it has also been registered on the app module by the Angular CLI. I've added it to the app component template right here using this tag. And then here's the template for the counter actions component. It just has two buttons right now. One is for the increment counter and one is to decrement the counter. We just have an empty TypeScript class for the counter actions component as of now. And then inside the app component's TypeScript class, we have a counter property that is set to 0 as of now. And one more thing is that inside the app component SCSS, we have a span with a font weight of bold and two classes defined. One is positive with a color of green and a negative class with a color of red. Now in the app component template, let me just comment out the input property section because we have already seen that. And let's see how this looks like in the application. So we have a message here that says the current value of counter is 0. And if I click on increment counter or decrement counter, nothing happens as such. Ideally in a working application, when I click on increment counter, the counter should increment by 1. And if I click on decrement counter, the counter should decrement by 1. If the counter value is less than 0, then it should show me in red color. And if the counter value is greater than 0 or equal to 0, then it should show me in green color. Now one catch here is that the increment counter and the decrement counter are a part of the counter actions component, as you can see here. So this is basically a child component and these buttons belong to a child component, while the counter that we have is on the parent component right here. So whenever an action gets performed on the child component, I need to update the value of the counter here on the parent component. So for that, we will need the counter actions component to tell their parent, which is the app component, whenever the button is clicked, so that it can update the state of the counter accordingly. So in order to do that, let's first implement the click listeners. So whenever the user clicks on it, I want to call a method, and let me just bind to the click event on the second button as well. And for both these buttons, I'm going to call the handle button method. Now, in order to determine which button called the handle button method, I'm just going to call this handle button method with an argument. In this case, it would be inc for increment and dec for decrement. So I can now implement this method inside the counter actions component. Let's say this is an operation which is of type string. And now let's log the operation to the console like this. So if I go back to the application and click on a button, I should see that when I click on increment, I see inc getting logged to the console, and on decrement, I see dec being logged to the console. And that's a good start. Now, like I said, in order for the parent component to know that there was an action that was performed on the child component, we'll have to bind to something on it using the event binding syntax. So for event binding syntax, we use these parentheses, and inside the opening and closing parentheses, we specify the name of an event that we want to listen to. As of now, this counter actions component doesn't really have an event. But let's say that the counter actions component had an event named counter change, and on that I had to call a method on the parent component in order to then set the state of the counter property accordingly. So I'll create a method and call it on counter change. And now we can also expect the counter actions component to tell us which button was clicked. So whether it was the increment button or the decrement button. So again, this is an event. In order to get the object which has the necessary information for the event, in the previous video we used the $event key, and that's exactly what we are going to use in this case as well. So I'll just copy this and save the app component template and implement this method inside the app component's TypeScript class. And in the event, let's say that I'll be getting the button type. So whether this was an increment button or a decrement button. And the value of this is going to be of type string. Now at this moment, I don't really have the counter change event on the counter actions component. So let me just quickly do that. The type of this is going to be event emitter. Now event emitter is something that we import from Angular core and not from events. So please pardon my auto import plugin for that. It should be imported from Angular/core. Now the event emitter expects a generic type T. So I'm pretty sure that I'm going to pass the button that was clicked in the form of a string. So I can specify this as a string. And then I'm going to new this up by calling event emitter constructor, just like this. Now inside the handle button method, I'll use the counter change property. So this dot counter change. Now the counter change property will have a method named emit on it, and this emit is going to expect a string because that's what we specified as the type for this generic type of event emitter here. And the operation is something that I'm already getting as a string, so I can simply pass that right here, and I'll save this. Now I have the counter change property on the counter actions component, which is our child component, and I'm using that and binding to it inside our parent component, which is our app component HTML, like this. Now inside this method that we are handling inside our app component, since we'll be getting the button type as inc or dec, we can accordingly set the state of the counter. So I can set it using a ternary operator. So if the button type is equal to inc, then I'm going to increment the counter. Otherwise, I'm going to decrement the counter. Now another thing is that we also have to show the counter value on the HTML here in either red or green depending on the value. So I can have another condition in here. After this counter has been updated, I can set a class to set property, which is, let's say, by default positive. And this is the CSS class that we defined inside the app component SCSS, this positive or negative. So I'll initialize it to positive because I want that when the counter is set to 0, it is positive. So here I'm going to set the class to set property to equal positive if this dot counter is greater than or equal to 0, else I'll set it to negative. So now I have the class to set property on my component class. I can use the property binding syntax, which is class here, and set the value of the CSS class like this and save. Now let's just go back to the application. Initially it is 0 and we have said that if it is 0 or greater than 0, then the color should be green. So that's what it is showing. Now let me click on the increment counter. So I click on increment counter and we are also getting this log, but I'm not seeing the counter to be updated. Now let's see what we are missing here. So we already have a counter change property, which is of type event emitter, and we are emitting with the operation that we got from the counter actions component HTML, and we are already seeing this being logged, which would mean that the counter actions component's handle button method is working just fine. Now this is an output property, but Angular is not going to know about this output property on the counter actions component until and unless we decorate this property with the output property decorator. And output property decorator is again something that we import from Angular/core. So now that I've decorated the counter change property with the output decorator, and I'm binding to the counter change property via the event binding syntax, and I'm saving this. This should work as expected now. So let me just clear the console and click on increment counter, and I see that the counter is being incremented. Let me do that quite a few times and it's working as expected. Let me just test the decrement counter now. So I'll decrement it, and I also see that the counter is being decremented. Let's also see what happens if we decrement it to less than 0. So let me just click that once more, and I see -1 being printed in red color, right? So this works as expected now. And this is how you pass some data from child to your parent component using the output property. So this is quite a long video wherein we discussed about the input property decorator, which is used to pass some data from your parent component to the child component using the property binding syntax. And to pass some data from your child component to your parent component, we use the output property decorator along with the event binding syntax. And now that we know the input and output property decorators, we will now be able to better understand and appreciate the two-way data binding syntax that we have in Angular. So that's the topic of the next video, and I'm going to see you guys in the next one. Alright, so now that we understand the input and the output property decorators, and we also understand how the property binding syntax and the event binding syntax works, it's finally time for us to now have a look at the two-way data binding syntax in Angular. So this is how the two-way data binding syntax looks like. We have a property here which is wrapped with a parenthesis, just like we have in case of the event binding syntax, and then that whole thing is wrapped with a square bracket syntax, just like we have in case of the property binding syntax. And here in case of the property, we supply the name of the property that we want to bind two ways. Now here we supply the name of the property and not really supply the name of the handler that would eventually handle the change on that property. But this is something that Angular does on its own in the background. So in case of two-way data binding in Angular, any Angular component or a directive can accept some input as an input property, and then it can also emit some event when that input property has changed as an output property. And then whatever this thing is then assigned can be considered as bound two ways. We can safely consider this as a blueprint for writing two-way data binding syntax in Angular. And as we have already seen in this diagram, the flow of data in two-way data binding syntax works both ways. So the data would flow from the template to the TypeScript class and vice versa as well. So let's quickly see how we can implement the two-way data binding syntax, extending the exact same example that we had a look at in the previous video. So we have the exact same counter actions component which is handling the counter change output property via a method that we have on the app component. And then in the counter actions template, we are calling the handle button with the type of action that was performed, whether increment or decrement. Inside this, we have this handle button method that then has an output property, and we are calling the emit method on the counter change event emitter and passing it the operation, which is then being handled inside the on counter change method inside the app component class. So this is how it looks like in code. We can click on increment counter to increment this value, and then we can also click on decrement counter to decrement it. Let's see how we can quickly change this thing to a two-way data binding syntax. So in order to make that change, inside the counter actions component, we will also have to implement an input property that is called counter, which is going to be of type number. And now the counter change property is already an output property, but then it emits a string. So instead of a string, let's emit a number. Now here, instead of the operation, we are going to change the counter itself. So if the operation is equal to inc, then we are going to change the counter. So this dot counter plus plus, else it's going to be a decrement operation. So this dot counter minus minus. And now instead of the operation, we are going to send out the counter itself. And the only change that we'll have to do inside the app component template is that we will now supply the counter, and then here instead of the counter change, we will specify the name of the input property. We'll wrap that with a parenthesis, and then we'll wrap this whole thing up with a square bracket syntax. And let's save this and go back to the application to see how it works. And now if I click on increment counter, the counter increments. If I click on decrement counter, the counter decrements as well. The only thing that you'll notice here is that now in case of the negative values, we are not seeing a red color, we are just seeing the green color. And the reason for that is the class to set was initialized to positive, but then it wasn't really changed because this method was never called. The change was then carried out through the handle button method that we have on the counter actions component. And that's why the color is not being changed. But apart from that, we are still able to see that the counter is getting changed, and we are able to see the updated counter value right here. Another quick thing here is that the counter change output property that we have here must always have this name, wherein we will have the name exactly the same as the input property, which is counter here, and the word change appended after that. So it can only have this exact same name. So basically, if this was, let's say, some number in the input property, it would have to be some number change in the output property. And let's quickly see that as well. So let's say some number. This would have to be some number change. And then we'll also have to update all these things like some number change. And then we'll have to make the exact same changes here. So this would be some number. So if I save this now and go back to the app, I should still see this working as expected. But let's say if I change the some number change to some number changed by mistake and save this, and if I try to run that again, it's not going to work. So you will always have to keep this in mind, that whatever is the name of your input property, just append a change after that like this, and then it should pretty much work as expected. So if I run this again, I should see the counter being updated. Now there's a very famous Angular directive itself that does this internally. So let me just show that to you as well. The name of this directive is ng model. So ng model like this. And then here we specify the name of something. Let's say the title, which we have here. Now to use ng model, we must have the forms module added to our app module in the imports array, which we don't have at this point. And that's why we are getting this red squiggly line here. The error here says that can't bind to ng model since it isn't a known property of input. So in order to use the ng model directive, we'll have to import the forms module and add it to the declarations array. So forms module, and forms module is something that we import from Angular/forms. So I'll import that from Angular/forms and save this. And now since I was getting this error and I added the forms module here and added that to the imports array, so it should now pretty much work as expected. Now, apart from that, let's also see what this prints. So title, save this. Now, if I go back to the application, I should see Angular here and is the best front end framework. So as soon as I update the text here, this update also gets reflected here. Right? If I clear this, everything gets cleared. Angular is the best, right? So it all works as expected now. And if you have a look at the implementation of ng model, you'll exactly see that. So the ng model directive has an ng model property as an input property, and then it has an ng model change property as an output property. And that's what we have seen regarding the two-way data binding syntax in Angular. So now we have understood all four major component bindings that we have in Angular. But apart from that, we also have some other bindings like the class binding, the attribute binding, and the style binding. And that's exactly the topic for the next video. So I'll see you all in the next one. Alright, so it's time for us to now understand the attribute binding syntax. But in order to do that and in order to appreciate what the attribute binding syntax does for us, it's first very important to understand what an attribute actually is. So HTML elements have attributes on them, and then when these HTML elements are rendered onto the browser also creates a JavaScript representation of these HTML elements. So most of the attributes that we have on the HTML element eventually transform to properties on the JavaScript representation of that HTML element, and this JavaScript representation is basically an HTML element JavaScript object. Now while doing that, the browser transforms mostly all the attributes on that HTML element to properties on that JavaScript object, but not all of them. So the attribute binding syntax is used when there is no element property that we can bind to. And this happens mostly in cases of area tags, SVGs, and table span attributes. So these are basically pure attributes, so to speak. That's why we cannot really set them via the property binding syntax. So in cases where we don't really have a corresponding element property to set, we use the attribute binding syntax in order to set these attributes. Now there is a very famous Stack Overflow thread that is going on for quite some time now, which essentially discusses about the difference between properties and attributes in HTML element, the link to which is given in this slide on the bottom left section. So this is how that thread looks like. It basically tells us that whatever we have as an HTML element basically transforms into an HTML element JavaScript object, and then this has some properties on it. Now let's quickly jump to Visual Studio Code and let's see the attribute binding syntax in action. So I've already created an attribute binding component inside the bindings folder in the components folder, and that has already been added to the app module right here in the declarations array. And I've also added the tag for it to the app component HTML. And inside the attribute binding syntax, I have a table with some table rows, some columns, and then there is a button to which we have to set some area attribute. And this is how it looks like on the view. As of now, the table doesn't look so balanced. Ideally, we could have spanned this through two columns. So that's what we are going to do now. So I'm going to apply a call span of 2 here. And I'm going to do the same thing for this column as well. And if I refresh it, it looks something like this, which is more balanced at this point. Now let's say that at some point in time we have like n number of columns here, and we wanted this row to span to the exact number of columns that we had in here, right? So that way we would have to do some sort of a calculation in order to set this particular attribute. Let's say that we had some array, and on that array we had some length property that we could bind to. So let's create that array quickly, and let's say that numbers is an array of two numbers, 1 and 2. And now on the numbers array, we are using the length property to set the call span here. So if I save this and go back to the application, we see that this doesn't really work at this point, right? Because this is an expression and this is an attribute that we want to set. Now generally we would use the property binding syntax somewhat like this. And if I save this and go back to the application, I get an error saying that we cannot bind to call span since it isn't a known property of the TD tag. If I go back here and check, call span is actually a pure attribute. So we cannot really bind to that using the property binding syntax that we are using right here. So in order to set this, I can use the attribute binding syntax. And in case of the attribute binding syntax, we prefix whatever attribute that we want to set with attr dot, something like this. Now as soon as I do that and save this, I should see that this particular row would span to two columns like this. Now call span is an attribute, and that's why we had to use the attribute binding syntax. But if we still wanted to use the property binding syntax, like say in this particular row, for example, we could use the property binding syntax, but then we will have to specify the name of a property that basically corresponds to call span, and which in this case would be a call span with a capital S, like this. I right now have two here, which should be numbers dot length again, like this. And if I save this, it should pretty much be displayed as expected. Now there are some accessibility related attributes as well that we might want to set, like the area label. So we might want to set this to, let's say, action name. Now action name is a property on the TypeScript class that we have right here, this one, and we wanted to set that here. So if I try to, let's say, use the string interpolation syntax in order to do that and save this, I'm going to get an error, and it would say that it cannot bind to area label since it isn't a known property of the button tag. So again, I'll have to try using the property binding syntax. So I try it like this, and here I'll just have to specify the name of the property to bind to, which is action name. So if I save this and go back to the application, I'll still get an error saying that it cannot bind to area label since it isn't a known property of the button tag. So again, I might have to try with the attribute binding syntax. So attr dot, something like this. And if I save this and go back to the application, it should pretty much set the area label for this button. Now in this case, we used call span with an uppercase S with the property binding syntax, but that is essentially not true every single time for every single attribute that we might want to set on an HTML element. So let's say, for example, if I try doing the exact same thing here by removing the attr and placing the L with an uppercase L, something like this, and save this, it's not going to work, and it's going to give me the same error saying that it cannot bind to area label since it isn't a known property of the button tag. So whatever we are doing in this case might not always apply for all the other attributes as well. So this is something that you should keep in mind while setting the attributes on HTML elements. So I'll just revert it back to the attribute binding syntax. So area label like this, and save this. And I should not get any error on the console anymore. Now as a rule of thumb, since there isn't any concrete documentation that specifies what all attributes can be set and what all can be set as property binding syntax, we must first try using the property binding syntax, and if we get an error something like the one that we got in this case, like this. So it says that it cannot bind to some property that we have here since it isn't a known property of some tag here. Then one of the option that you might want to try is the attribute binding syntax, which is attr dot, and then you supply the name of a property like this, and then it should work as expected. So if I save this and go back to the application, we are able to set the area label without any issues. So just to recap, we can use the attribute binding syntax when there isn't any element property to bind to, and we can set attributes in these cases where we don't have a corresponding element property. Now again, if you want to know more about the difference between properties and attributes in HTML element, then just have a look at this Stack Overflow thread and you might be able to better understand much about this whole thing. Finally, like I said, since there isn't any concrete documentation related to the attribute binding syntax anywhere, you should first try using the property binding syntax in order to bind to a property. But then if you get an error saying that cannot bind to a specific property since it isn't a known property of some HTML element, then you should try using the attribute binding syntax, something like this, and most probably in most of the cases it should work as expected. If you still get some error, feel free to contact me on the queries section of the course and I'll be able to help you out with that. That brings us to the end of this video. In the next video, we are going to talk about the class binding syntax. So I'll see you all on the other side. In the last few videos, we saw how we can use the attribute binding syntax and the property binding syntax in order to set some attributes and properties on HTML elements respectively. But there are cases wherein we might want to conditionally set a CSS class onto an HTML element. Now we might try using the property binding syntax and the attribute binding syntax just like we have here in order to set these CSS classes. But what this is going to do is it's going to override the previously set CSS classes onto our HTML element. And we might want to just toggle a specific CSS class without actually overriding the previously set CSS styles onto an HTML element. So to do that, we can use the class binding syntax. Now generally ng class directive is preferred in order to do this, but since we haven't really seen the ng class directive, let's first see how we can use the class binding syntax in order to toggle a specific CSS class. In order to save some time, I've already created a class binding component right here, which sits inside the class binding folder inside the bindings folder. The component we have here is already been added to the app module in the declarations array. And I've already added the CSS selector for this component inside the app component HTML. Now there's nothing as such inside the component class, but we have some CSS classes on the class binding components SCSS file. So there's this bold class that sets the font weight to bold. There's a curly class that sets the font style to italic. There's a red class that sets the font color to red. And then there is a highlight class that we might want to conditionally add to a bunch of these CSS classes that we have already added to a div on the component HTML right here. So as of now, this is how it looks like. We have this text that gets rendered with a color of red, a font style of italic, and a font weight of bold. And there is this button that does nothing at this point. But our intention is to add some class to this text when this button gets clicked. So let's first see how we can not use the attribute binding syntax and the property binding syntax in order to achieve this. And the class that I want to add is the highlight class. Let's first try using the class binding syntax. So here is the name of this property that I want to add. And if I save this and go back to the application, I will see that the highlight is being applied onto the text, but I lose out on all the previously set CSS styles. I might also want to try using the attribute binding syntax in order to do this, but this is going to essentially result in the same behavior. So I still lose out on all the previously set CSS styles. So in order to do this, I'll just use the class binding syntax. So that starts with class dot, and then here we specify the name of the CSS class that we want to apply. So that would be highlight. And on the right hand side, we will specify the condition that either resolves in a true or a false. So add highlight is a boolean that we have created on the fly in the template. So I can just set that here. So if add highlight is true, then it is going to add a highlight class. If it is false, then it is going to remove the highlight class. So it's essentially going to toggle the highlight class onto the previously set classes that we have here. So if I save this and go back to the application, I should see that the previously set styles are there in place. It still has all these styles. But if I click on highlight now, I will see that a highlight class was added as well. And let me just check that out here. So a highlight class was added to this div. If I click that again, I'll see that the highlight class got removed. And again, and again. Now, as I've already said that instead of using the class binding syntax, generally the ng class directive is preferred, but you can still use the class binding syntax in order to optionally add or remove a specific CSS class without overriding the previously set CSS styles. So just to recap, if we try to use the property binding syntax or the attribute binding syntax in order to toggle a specific class onto an HTML element, we are going to lose out on the previously set CSS styles. So the new style is going to essentially override the existing styles, which is something that we might not want every single time. So in order to just toggle a specific CSS class from an HTML element, we can use the class binding syntax, and we have already seen the syntax for it. That brings us to the end of this video. In the next video, we are going to talk about the style binding. Alright, so now after having a look at all those types of bindings in Angular components, it's finally time for us to have a look at the last type of binding, and that is the style binding. Now style binding is almost similar to the class binding, but instead of the class name, we prefix the style name with style dot. So here are a few examples. This thing sets the color of the particular HTML element to green if isValid is true and red otherwise. This sets the font size in pixel to 30 if isBig is true and 10 otherwise. This sets the background color to cyan if isValid is true and gray otherwise. So these are a few cases wherein we might want to set these style properties conditionally, but these can also work without any condition. So we'll just have to specify the value here of the property that we want to set here, and it would all work as expected in that case as well. Now there might be cases wherein you might want to set multiple styles, and so we might have to use multiple style bindings. So in those cases, the ng style directive or the CSS classes are preferred. So let's quickly see how we can use the style binding in VS Code. So to save some time, I've already created a style bindings component. It has already been added to the app module right here. And I've also added the selector for that component in here on the app component. There are a few divs here with a few buttons with just normal text in there, and nothing is happening as of now. This is how it looks like on the view. Now let's quickly add a few style bindings in place so that we could easily understand what it is all about. So in case of this button, let's say that I wanted to set the color style of this button, and that would be dependent on the property. So let's say that if isValid is set to true, then I would like to set the style color to green and red otherwise. So if I save this and go back to the application, as of now, this is set to red because initially we don't really have any specific isValid property, and that can be checked if you have a look at the component as well. The component is empty as of now. So there is no isValid property, and that's why it's set to red. But if I click on this, then it is going to generate the isValid property on the fly and then set it to false in this case. So that's why the color now turns to green, and that's why we are seeing the green color here. So if I now toggle this on and off again, I'm going to see the green color and the red color for this button. So this is how you can set the color property on the styles of a button conditionally based on whether the isValid property is set to false or true. Next up, if we want to set the background color of this div, let's say, I'll just do it like this. So style dot background hyphen color, and I'll set that to yellow, let's say. If I save this and go back, this should set to yellow. Now if we wanted to set multiple properties on the style, we might have to use that multiple times. So let's say for example, if I wanted to set the background color to red, and if I also wanted to set the font weight property, so font hyphen weight, I can do that here and I'll set that to bold. If I save this, this should turn red and with font weight as bold. Right now, another thing that can be done is instead of this hyphenated style property, we can also make this camel case. So font weight without a hyphen and W in uppercase. So if I save this and go back to the application, it should still work as expected. So these are the two ways of setting a specific style property. You can just set it like this, or you can also name that style property in camel case. Another thing is you can also set some values wherein you might want to set, let's say, the scale of this particular property. So let's say that if we wanted to set the font size property on this div, we can do that either in percentage or in pixels or in EM. So let's quickly try doing that. Style dot font size dot. Now this one is in percentage. So let's say that I wanted to set this to 5%. So I'll save it like this. And if I go back to the application, I should see the font, but it is in very small size, so it's not visible at this moment. So instead of 5, let's say that I set that to 50 and save. So it will now be visible in 50% size. If we talk about pixels, I can do the exact same thing. Instead of percentage here, I'll just set that to px. So this would be taking the font size of 50 pixel now. If I save this and go back to the application, this is 50 pixels in size. Finally, we can also set this to EM. So if I set this to EM now, and 50 EM would be way too big. So I'll just set it to, let's say, 5 EM. If I save this, I should see 5 EM in place, and even that is way too big. So these are a few ways in which we can use the style binding in order to set a few styles. But as you can see here, this has some issue wherein we might want to set multiple styles on a particular HTML element. So in that case, either a CSS class or ng style directive should be used. And that brings us to the end of this video. Just to recap, we saw that this is similar to the style binding, wherein instead of the class dot keyword, we specify the style dot keyword and then specify the style name, and after which we specify the value. So this can be an expression or it can simply be a simple value, as we have seen in the examples. This also brings us to the end of the series of videos wherein we talked about component bindings and all these different types of bindings that a component can have. Next up, we are going to talk about the component lifecycle hooks. So I'll see you all in the next one. Alright, so what exactly are lifecycle hooks? Well, lifecycle hooks is a concept that applies to components as well as directives, and you can think of components as a specific type of directives only. Directives that have templates. While structural and attribute directives don't have a template, components do. Now you might think, what exactly are structural and attribute directives, because we haven't really talked about it. Well, don't you worry about it, because we are going to cover directives in the next section of this course. But just for the sake of this video, whenever I talk about lifecycle hooks, please do consider them as some things that apply to both components as well as directives. Now what exactly are lifecycle hooks? Well, a component or a directive has a lifecycle that is managed by Angular. Angular is responsible for creating them here being a component or a directive, rendering them, creating and rendering their children, checking their data bound properties, and destroying them before they can be removed from the DOM. So Angular provides us with some lifecycle hooks that can help us tap into these key life moments of Angular components as well as directives so that we can act accordingly whenever they occur. Now in case of Angular, these lifecycle hooks are implemented as some sorts of interfaces. So when you implement these interfaces on the component class or the directive class, then you also implement methods that eventually gets called when these particular key life moments occur. Now you'll see that the name of the interface, if it is prefixed with ng, then it would be the name of the method that you will implement in your component or directive class. Alright, so let's now talk about sequence of execution. Now, we already know that almost everything inside Angular is essentially a TypeScript class, and so is a component or a directive. So, both these components or directives will eventually have a constructor function, so that gets called whenever this component or directive gets instantiated by Angular. But then after that, the first lifecycle hook gets called, which is ng on changes. After that, ng on init gets called. Now, as you can see in both of these lifecycle hooks, both the methods that gets called are prefixed with the ng keyword, and then after that is the name of the interface that implements these lifecycle hooks. So onChanges is the name of the interface that implements the onChanges lifecycle hook, and the method that gets called when that specific key life moment occurs is ng onChanges. And so is the case with ng on init. After ng on init, ng do check gets called, then is ng after content init, then we have ng after content checked, then we have ng after view init, then ng after view checked, and finally we have ng on destroy. Now these are a few lifecycle hooks that you will eventually wrap your head around, but just don't worry about them at the moment if you're not really able to understand everything just yet. With time, you'll get a hold of it, and then you'll actually feel a lot more comfortable using these lifecycle hooks. So, when exactly are they called, by the way? As I've already told, the constructor, which isn't really a lifecycle hook, gets called every time Angular instantiates a component or a directive. Next up, we have ng on changes. Now, ng on changes gets called every time one of the input properties on a particular component or a directive gets set or gets updated. Now we already know what these input properties are because we have talked about that in one of the previous videos. So whenever these properties that are decorated by the input decorator are changed, then ng on changes gets called. But this change can happen a lot more frequently, right? So ng on changes will get called again and again as well. And that's why I've also placed a warning sign right before the name. This is just to let you know that this particular method gets called frequently, and so if you implement the method, then it will cost you performance. So you might not want to do that. This is just some sort of an indication in that direction. Next up, we have ng on init. Now, ng on init gets called only once in the lifecycle of a component or a directive, and just after the first ng on changes. Then we have ng do check. Now, ng do check gets called every time Angular performs change detection on a particular component or a directive. Now, you might think, when exactly would Angular perform change detection? So, well, Angular performs change detection in mostly three cases. So, in case of timeouts or intervals, wherein if you call the set timeout method or the set interval method, then Angular performs change detection. Next up, we have DOM events. So, whenever there is a button click, or if there is any keyboard specific event like key up or key down or something like that, or there is a change event in case of select lists or any such DOM event, then Angular would perform change detection. And then finally, in case of AJAX requests, like say for example, if you're making an API call to some REST API, then that would also trigger change detection. Angular performs change detection in these three cases, and every time Angular performs change detection, ng do check gets called. Next up, we have ng after content init. So ng after content init gets called only once in the lifecycle of a component or a directive, and it gets called when Angular finishes projecting content onto a component. In case of directive, this gets called if this directive sits on a component on the top of which Angular performs content projection. Now, what exactly is content projection? Content projection is somehow similar to ng transclude if you come from an Angular JS background, but you can just think of it in this way, that if the child component has this special tag that is ng-content, and you pass some HTML markup in between the opening and closing tag of a particular component selector, then that is the projected content that will get projected onto this child component. And that's basically what content projection is. So just to help you visualize, let's have a look at this example. Now, this is a very simple example wherein we have two components. We have the app component and then we have the hello component. Now, inside the hello components template, there is this ng-content tag. And then from the app component HTML wherein I have used the hello component, between the opening and the closing tag of the hello component, I have passed this content, which is a paragraph tag, and then it says this is the projected content. And so right below this h1 tag, where I actually have this ng content tag, this is exactly the place where the projected content gets placed, right? If I cut this from here and then move it to, let's say, above the h1, then we will have the projected content over here, right? So this is just what projected content is all about, and this is what content projection is all about. So coming back to the point, whenever Angular finishes projecting content onto a component or a directive that sits on a component, then ng after content init gets called. Next up, we have ng after content checked, which gets called every time Angular runs change detection. So it runs for the first time right after the first ng after content init, and every time Angular runs ng do check. Next up, we have ng after view init. This gets called right after the first ng after content checked, and this gets called after Angular has performed initializing the template of a particular component. Or it gets called in case of directives when the template of a component on the top of which this directive sits has been initialized. Then we have ng after view checked, that gets called right after the ng after view init, and every time Angular performs change detection, but after ng after content checked. And finally, we have ng on destroy. This gets called immediately before Angular destroys that particular component or directive. So now that we have seen the sequence as well as the specific instance at which these lifecycle hook methods gets called, let's now also have a look at the frequency of these calls. The constructor runs only when Angular initializes or instantiates a component or a directive class. So the constructor is going to get called only once. Now again, constructor is not a lifecycle hook, but it is just a method that gets called during this lifecycle of a particular component or a directive. So we will still consider that as a method that gets called here. Next up, we have ng on changes. Now, like I said, this gets called every time there is a change in one of the input properties of a component or a directive. So every time there is a change, ng on changes is going to get called. So again, it will get called quite frequently. Next up, we have ng on init. This gets called only once right after the first ng on changes. Then we have ng do check, which gets called every time Angular runs change detection. Then we have ng after content init that gets called only once right after the first ng do check and after Angular has finished projecting content onto a component. Next up, we have ng after content checked, which again gets called every time Angular runs change detection. But if you see the sequence, it runs after ng do check and ng after content init. But again, every time Angular runs change detection, so it will get called again and again, that too quite frequently. Next up, we have ng after view init, which gets called only once when the view of a component has initialized. Then we have ng after view checked, that also gets called every time Angular runs change detection. And then finally, we have ng on destroy. Now the methods that gets called only once have this specific emoji right besides them, while the methods that gets called quite frequently have this 100 emoji right besides their name. This is just to help you visualize and have a mental model of how many times a specific lifecycle hook method gets called. Now one more thing to note down here is that if this lifecycle hook method name has init in there, then you can feel safe to actually use them for specific use cases. What are these use cases? We'll talk about them in the next video. But yeah, if the name of these lifecycle hook methods have init in there, then you can feel safe to use these methods. And this is also the case with ng on destroy because that also gets called only once. But in case of methods like ng on changes, ng do check, ng after content checked, and ng after view checked, you have to keep in mind that these are a few methods that will get called again and again quite frequently. And so if you implement these methods in your component or directive, then it would cost you a lot of performance. So you have to keep that in mind while implementing these methods. So I hope this video helps you with understanding of the sequence of these lifecycle hook methods, when exactly do they get called, and what is the frequency of these calls. In the next video, we are going to talk about how we can actually implement these lifecycle hook methods in code, and we'll also have a look at a few use cases in which we should use a specific lifecycle hook method. So I'll see you all in the next one. Alright, so now that we know what lifecycle hooks are, how frequently do they get called, and what are all these specific instances in which they get called, let's now finally have a look at the use cases in which we can use a specific lifecycle hook method in Angular components as well as directives. So, what are these use cases? Well, for the most part, you won't even have to implement all these lifecycle hook methods in each of your Angular applications, and you would just get by with a few of them. But still, specific lifecycle hook methods are meant for specific use cases. So let's talk about them. The ngOnChanges lifecycle hook method is used when you want to act upon changes to the data bound input properties. The ngOnChanges lifecycle hook method gets called with a sample changes object as an argument, and this object actually has information about the previous and the current value of that particular input property. Now, in most of the cases, you might not even have to use it in the first place. Next up, we have ngOnInit, and we generally use it quite often to initialize components or directives properties. And from this video onwards, throughout the rest of the course, we will be using ngOnInit quite a lot for initializing components or directives properties. Next up, we have ngDoCheck. Now, ngDoCheck is meant for you to handle changes that Angular didn't detect. So if there are specific instances which you might generally come across if you are using some sort of a third-party JavaScript library, Angular might not detect changes in a few scenarios. And if you want to detect changes for these specific scenarios, then you can write that logic inside ngDoCheck. But for usual cases, you won't even have to do it because Angular is actually pretty good at change detection. Next up, we have ng after content in it, and we generally write logic to access projected content in this particular lifecycle hook method. So if you want to access some projected content and then maybe make some changes to some properties on that projected content, then you can use ng after content in it to do that. If you try to access that projected content before ng after content in it gets called, then you might end up getting an error because the projected content will not be initialized before this method gets called. Next up, we have ng after content checked, and you can use it to respond after Angular has checked for the projected content. Now, to be honest, I've never used this specific lifecycle hook method, and in most of the cases, even you might not have to do that. Next up, we have ng after view in it, and this is also quite often used when you want to have access to a component's view or its child's view. And we will actually use both the ng after content init as well as the ng after view init methods in the next video when we talk about view queries. Then we have ng after view checked, and this is almost similar to ng do check and ng after content checked. So you can use it to respond after Angular has checked for the components or the child's view. But again, this is rarely used and you might end up not using it in the first place. Finally, we have ng-on-destroy, and this is one of the major lifecycle hook methods that gets used quite often. You can basically think of this method as a space wherein you can tear down anything that you might have set up. So if you have made calls to the set timeout or the set interval method, you can clear those timeouts or intervals in here. If you have added event listeners, then you can detach those event listeners here. If you have made an API call and you've subscribed to that observable, then you can unsubscribe from that observable in here. Now don't really worry about observables at this point because that is for the scope of one of the later sections. But just bear that in mind that ng on destroy is a place wherein you can do all these sorts of cleanups. Alright, so now enough talk. Let's now jump into the code and see how we can use these lifecycle hooks in action. So just for the sake of this video, I will be continuing the exact same application that we built in our first assignment. This is the very same node list application that we built together. Now, I've made a few small changes to the application so that I can show you the usage of lifecycle hooks in Angular components. So let's quickly see what those changes are. So I just have the app components template wherein I have used this note list, which is this component right here. Now inside this note list, I have the exact same note string and the notes array. This is of type note instead of just string. Note is actually a model that I've created. So it is an interface that just has the message property, which is of type string. So inside the note list component, there is this note, which is just a string, and the notes array, which is an array of note. Then we have the similar add note method, which just pushes a new note to the notes array. The object is being created right here on the fly with the message property, and the value to it is the note which we have right here. And we also then reset the note to empty. And then we also have introduced this new method, that's change first note method. It just changes the message property on the note present at the 0th index on the notes array to some changed string. And then we just have this delete note method that expects the index of the note it needs to delete, and then it uses the splice method to delete that note from the notes array. We also have added a new method that's called trigger change detection, and this is something that we will call once the user clicks on this newly added button. We also have this change first note button, which will call the change first note method right here. So if I jump over to the note list component template, we have this h4, then we have this input, which is bound two ways via ng model to this note property that we have. And once the user clicks on enter while typing in a note, we call the add note method. And then we have these two buttons, which we see right here. This calls change first note, which changes the note present at the 0th index. And then we have this method that gets called when the user clicks on this orange button that says click me to trigger change detection. And then finally we have this notes list, which is again similar. Here we have this unordered list, and inside this unordered list we are iterating through the notes array that we have on this component, and then we are initializing the app note list item child component. Now to this child component, we are, instead of just passing in the note and expecting the delete note output event from there, we are also passing it a note index. The note index is something that I've tried to access from the index property from this ng for structural directive. So I just get a hold of the index and assign it to a variable that was created on the fly, which is named I, and then I pass this I to the note index. Now inside the note list item component, we have these two input properties, which is the note, which is the string message that we pass, and the note index, which is a number. And then the output property here is this delete note, which emits an event of type number. And there is this handle click method wherein in the note list item components template, once the user clicks on the delete button, then the handle delete click gets called, and that emits the delete note event with the note index, which eventually calls the delete note method on the note list component, and that's how the note gets deleted. So far it's all working as expected, so let me just quickly show you how it works. I type in the name of a note, I press enter, and then I see that note being listed right here. I can actually do that several times in order to add more notes. Now what happens is, once I click on this change first note, then this changes this particular note message. So if I click on this, then you'll see that this gets changed. And the delete functionality as well is just working as expected. So if I click on delete, the notes get deleted, and once the last item gets deleted from the note list, then I see this placeholder message saying please add notes to see them here. Now I'll be implementing these lifecycle hook methods inside the note list item component, which is the child component. Now all the action will happen right inside this note list item component. Alright, so this has a constructor method which gets called every time Angular instantiates this particular class. So that would happen as soon as I type in a new note. Once I press enter, then you will see that something gets logged here onto the console. I've also styled it a bit so that you can actually differentiate between multiple logs as such. So as soon as I press enter, you will see that there is a log getting printed onto the screen, and this log is coming in from the constructor. Now here I've also tried to print in the value of the note, but it is undefined at the moment. So that is the first thing that gets called. I've actually, for the interest of time, also implemented all these component lifecycle hooks. So I'll just uncomment all of them at once. And one best practice that is recommended by Angular is to actually implement interfaces that enforce us to implement these methods on our component class. These are a few interfaces that needs to be implemented. So I'll just copy them and then I'll implement them and then finally get rid of this comma from the end. And everything now works as expected. Let's see what happens as soon as I add a new note. So let's say note 1, I press enter, and you will see a few logs being printed onto the screen. So let's go through them one by one. The first one is coming in from the constructor, which gets called when Angular instantiates the note list item component. Then the ng on changes gets called, and this gets called with something that's called simple changes, as you can see right here. Simple changes is just an object that tells you about the things that have changed as far as the input properties are concerned. So as soon as I added a new note, then the note property got changed. Its current value is note 1 and it is first changed. So that's why the first change is set to true. There is also this note index property, the current value of which is 0, and that is also changed for the first time. So that's what we see right here in the ng on changes. Next up, ng on init gets called, and that gets called only once. So you'll see that the lifecycle hook methods that gets called only once are actually styled in green, and the ones that gets called quite often are styled in this yellow or orange color. I've also tried to log the value of note inside ng on init, and you'll see that the value is note 1, which is expected, and that is coming in from this ng on init method. Next we see that ng do check gets called right after ng on init. Then we have ng after content init that gets called after ng do check. Then we have ng after content checked. Then we have ng after view init, and then ng after view checked. And after this, you'll see three methods being called again and again, which is ng do check, ng after content checked, and ng after view checked. And they get called twice. So that's exactly what I was saying, that ng do check, ng after content checked, and ng after view checked gets called again and again every time Angular performs change detection. So let me just clear everything right now, and let's click this button so that it triggers change detection. Now clicking a button is essentially emitting a DOM event, and whenever there is a DOM event, Angular will trigger change detection. So as soon as I click this, you will see the do check, the after content checked, and the after view checked methods getting called, and they will get called again and again every time I try to click the button. Alright, now I also said that ng on changes gets called every time there is a change in one of the input properties of a particular component. So there is this change first note button which changes the message property on the note object, and as soon as I do that, the input property to this child component, which is the note list item component, is going to change, and you will see ng on changes log getting printed over here, along with the ng do check, ng after content checked, and ng after view checked calls. So as soon as I click on this button, you'll see that this gets changed to the string this just got changed, and you will also see ng on changes, then ng do check, then ng after content checked, and ng after view checked. So that is something that you'll have to keep in mind every time there is a change in one of the input properties of a component or a directive. Ng on changes gets called. So again, all these four methods gets called again and again, and if you implement them inside your Angular component or directive, then it might cost you a lot of performance, which is something that you might not want. So always keep that in mind. Now I'll be talking in a greater detail about ng after view init and ng after content init in the next video where we talk about view queries. So please bear with me on that. Now let me just comment the rest of the things out so that we can focus on the things that are important for this video, which is ng on init and ng on destroy. Now I've said that ng on init is actually a lifecycle hook method that we use quite often to initialize some property on a component or a directive. So that's exactly what we are going to do next. Now we'll get some red squiggly lines because we commented out all the rest of the lifecycle hooks, but we actually have the implements for all these lifecycle hook interfaces. So I'll probably have to get rid of them from here as well. So let me just do that quickly. And as soon as I do that, you'll see that red squiggly line to go away from the note list item component. Now, let's say that this component had a timer, which is of type number, and I've initialized it to 0. And I wanted to initialize that timer and increment it every time after 1000 milliseconds. So what exactly am I going to do for that? Well, I will call the set interval method here, and inside the callback method that we give to it, I will increment the timer by 1, and then I'll also log this particular string to the console. Now there is this interval ID that is returned by the set interval method, so I can assign it to another property that we have right here. Let's save that. So what I should expect is that every time there is a new instance created for this note list item component, ng on init gets called, and ng on init initializes the interval ID as well as the timer. And we can also see that being logged to the console. We have also actually used that timer inside the template right here for the note list item component. So now let me add a new note. So note 1, I press enter, and then I see this timer running which says 1, 2, 3, 4, so on and so forth. So it gets incremented after every second. But there are chances of memory leaks if you don't really clear this interval before Angular destroys this particular component. Now, when Angular destroys a component, right before doing that, it runs ng on destroy. So ideally, there is a method called clear interval that we can use to clear this interval before Angular can destroy the instance of this note list item component. But if we don't do that, then we will end up with a memory leak. What exactly is a memory leak? Well, you'll just see that in action. So I have this set interval method from where I'm logging this string to the console, and I'm also seeing this string being logged after every 1 second. If I clear this, I still see that running. I click delete node, and with that I should also see this timer logging stop. So once Angular destroys this component, everything that is related to this component should actually vanish, right? And that everything would also then include this log that we see on the console, right? So as soon as I click on this delete node button, I should see that this logging on the console stops, right? That should ideally be the expected behavior. So let's try doing that. Let's try clicking on this delete node button and see if this logging stops. So I click on delete node. The component gets deleted from the DOM, but I still see logging on the console, which is actually a memory leak, right? So how exactly do we avoid this? Well, I've also assigned this interval ID by calling the setInterval method. So I can just call the clearInterval method and pass it the interval ID so that it doesn't really lead to a memory leak and the interval can get cleared. So let me just reload the application now and let's try to do the exact same thing once again. So I'll type in note 1, press enter, and as soon as I do that, I see this logging getting started. But this time around, if I click on delete note, since deleting the note will call ng on destroy, and inside ng on destroy we have called clear interval with the interval ID for this particular set interval method, this logging should also stop. So let's try doing that. I click on delete note and the logging stops. And so this is not just applicable for intervals, it's also applicable for every other thing like set timeout, subscribing to observables, listening to events. So let me just also give you a quick example of the set timeout method, wherein I call the set timeout method, which gives me the timeout ID, and then I'll store that timeout ID in this timeout ID property that I have on the note list item component, and it logs this particular string to the console after 5 seconds. If I type in note 1, press enter, then I should see logged from set timeout being printed after 5 seconds, which is something that we see right here. Okay, but let's say that I wanted to delete the note right before the initial 5 seconds. Well, in that case, this log should not happen. So let's try doing that. If I type in note 1 here and then press enter and then delete it right up front, then I should ideally not see that logged from set timeout, but then I do see it, which again is because of a memory leak. And the reason for that is that in the ng on destroy, we didn't really clear the timeout. But as soon as I do that, and if I try to do that exact same thing again, so I type in note 1, press enter, and then I delete it right before 5 seconds. Now this time around, that log that I placed here inside the set timeout will not be printed onto the screen in the console. So this is another example wherein I prevented a memory leak from a set timeout. Similarly, just in case if you are using a third-party JavaScript library and you have to somehow add event listeners on some targets, you can also clear those event listeners by calling the remove event listener from that target. And similarly, you can do that exact same thing for observables, which is something that we will be having a look at in one of the later sections of this course. Now, one last thing that I wanted to point out here is the importance of implementing these interfaces. Now, implementing these interfaces is actually completely optional. So if I get rid of this implements keyword, even in that case, things should totally work as expected. I should still see logs getting printed onto the screen, and clicking on delete should also stop those logs. So everything should ideally work as expected. But it is still recommended to implement these interfaces for specific reasons. So let's say that you were typing in a hurry and then you somehow missed an alphabet from the method name, right? In that case, Angular will throw an error and it will say that you have incorrectly implemented on init. So for the sake of avoiding these specific scenarios wherein in a hurry you might mistype the name of the lifecycle hook methods, it is always ideal to actually implement these interfaces as well. Great. I hope this video gives you an understanding of the use cases for which you should use specific lifecycle hook methods, and I also hope that the code example was clear. If you just want to go through the code once again, here's that link to this sample stack blitz that I was working on. So please feel free to go through this code again and again to actually understand what's happening in there. And hopefully after you go through it and take time understanding it, things would be more clear. That brings us to the end of this video. In the next video, I'll be talking about view queries and how we can actually use view queries to implement component interaction. So I'll see you all in the next one. Okay, so let's talk about view queries now. What exactly are view queries? You can think of view queries as a way to get a hold of a reference to an element that you might have in the template. So consider this example wherein you have something inside your HTML template and you might want to have a reference to that element inside your TypeScript class so that you could do something with it. So you can do that with view queries. In this video, I'll be talking about view child, which is just one of these 4 view queries, the others being view children, content child, and content children. So view child helps us to get an element reference that we might have in the view of a component. View child looks something like this, wherein you just use the view child decorator. The decorator is having a selector, then you can pass an additional configuration object to this decorator, specifying the thing that you want to read and whether it is going to be static or not. Then you specify the name of the property on your class and then the type of this property. Now you can obtain references via different things, and these different things are the selector that I was talking about, which is this property right here. This selector can be anything like a component class, a directive class, a template variable, a service, or a template reference. Now we won't be talking about services just yet because that is something that we will be discussing as a part of a later section in this course. But let's see how we can specify a selector with other different things like a component class or a template variable name or template reference. So I've created a very simple project here with just 2 components. There's a hello component which acts as a child component. And then in here I have an input property and a private property. Then there's also a public method here called log something. Then I have the app component. Inside the app component, I have used the hello component 2 times. In first case, I'm not specifying any template variable for this component, but in the second case, I'm specifying hello as a template reference variable. Below that, I also have an input field, and for this as well, I have specified the template reference variable as input. Finally, I also have an ng template tag, and for this I've specified the template variable name as template ref. And this is how it looks like so far. So we have 2 hello components and an input field. Now let me just open the app component TS. I've already typed in some code in order to save some time, but let me just quickly explain. So the first thing that I'll be talking about is the selector. Let's say that there is a view child here. This view child is referencing the hello component that we have right here. So the way view child works is that we use the view child decorator. This is the decorator that I'm importing from Angular core that I've done right here. Then to the view child, I specify the selector. So if I just hover over view child, you'll see that it requires a selector as the first argument, and the second argument is the options object, which is optional. And both these fields inside this options object are optional as well. So that's why I'm just specifying the selector here, which is the hello component, which in this case is the child component as well. And then I specify the name of the property and then the type, which is hello component itself. I'm trying to get a reference to the hello component that I have inside this template in my TypeScript class right here. Now in the previous video about lifecycle hooks in components and directives, I said that anything that you have inside a template will only be accessible to you inside the TypeScript class once the view has been initialized. So this is something that we are trying to reference from the view. We will only be able to have access to it once the view has been initialized. And I can actually prove that to you by trying to access this inside ng on init. So let me try doing that. I'll just log this hello component inside ng on init, and let's check if we get something on the console. So I open up the console and I see that the hello component is being printed as undefined. The reason for this again is that this property on the TypeScript class that we have right here won't be available until the view has been initialized. and the view will be initialized only after the ng after view init lifecycle hook method has been called. So I'll try to do that exact same thing inside the ng after view init method, and this would be ng after view init. So I'll save this, and you see that we now inside the ng after view init have access to this hello component. There is this name property in here which is set to Angular. Let me open this up in a new window so that it's a bit more clear. So here's the console, and as you can see in ng on init we get undefined, but in the ng after view init, which gets called only after the view has been initialized, it gets initialized to this object. So that's the first way in which you can have access to the hello component that we have inside the template right here. But we also have a hello component with a template variable assigned to it. So we can also have access to this hello component using this hello template variable. And in order to do that, we have to specify hello instead of hello component here as the selector. Once I do that, let me just again try to do the exact same thing by logging both these things to the console. So I'll log it inside ng on init, and I'll log it inside ng after view init. Let's save, go back to the application. Now in ng on init logs, you'll again see that both of them are undefined, but in ng after view init, you'll see that both of them are defined and having the appropriate values. Next up, we have this input field, and we are referencing this input field via this input template variable. So I can have access to this input field as well, just the way I did it for this hello component using the template variable name as the selector. So here's our input field, and I can then try to print that out as well inside ng on init and also inside ng after view init. Let's save this, go back to the application. Again, things are undefined here but defined here. Now you'll also notice that by default for the hello components I was getting the type as hello component, but for the input field I'm getting the type as element ref. That is also something that I've specified over here as the type, right? So far we have looked at the selector. Now let's also have a look at read properties. Now if we don't specify read property, then we will get whatever default value this view child gives us. So if we don't specify any value to the read property, then we'll get whatever Angular gives us by default. But if we do specify something, then we'll probably get that. So the things that can be specified here are element ref, view container ref, or template ref. So let's see that in action. Now for this, I'll be trying to do the exact same thing with the hello component first, and this is the variable that I've created named hello component with read. Here I'm specifying read as hello component. So this statement right here would just act the way this statement was acting. So it's not really necessary in this case to provide the read property, because the statement that we have on line 26 and the statement that we have on line 21 both will act as the same. So they will both print the exact same thing. Let me just comment whatever we have inside ng on init, because we now get the general idea that things won't be available to us in ng on init. They will only be available to us in ng after view init once the view has been initialized. So let me try to log that to the console. So I'll log hello component with read, and this would just give me the exact same thing as I got right here for the hello component. Next up, we can read the hello component as an element ref as well. So that's exactly what I'm trying to do here. So in this case, I'm specifying the selector as hello component, but I'm reading element ref from here. So if I try to log this to the console now and save this, go back to the application, you'll see that here I was getting the hello component, but here, since I read that as element ref, it would give me some other things like this native element and then a few other properties that we would have on an element ref. Now, if you are wondering what an element ref is, you can think of it as a wrapper that would hold the JavaScript object representation of some HTML markup. So that JavaScript object representation is present inside this native element property, and you can also see that in action because here you'll probably have an inner HTML property, and then that inner HTML property would have the inner HTML for this particular component. Next up, we can also read this hello component, which was specified with a template variable as an element ref. So in order to do that, I'll again use the view child decorator and specify the read property as element ref, and then I'll also specify the type of this property that we have on the component class as element ref. So if I do that and try to log this onto the console, I'll get this exact same element ref that I used to get for the log above. Apart from that, I can also read this as a view container ref. I'll try to do that for both the cases wherein I've specified the selector as the hello component and as hello, which is the template variable name. So let me just uncomment both these statements and let me just copy the names of the properties and let's log them to the console. So this is hello component and then this is hello component via variable as vcref, and the value to it would be this, which I want to log to the console. If I go back now, these were the two element refs that were getting printed. The next thing that we are printing here is the hello components being read as a view container ref. Now, what exactly is a view container ref is something that I'll explain in the next section of this course where we are creating custom structural directives. So I'll talk about view container refs in there, but just bear with me for now and just remember that this is something that can be read as well via the view child decorator. And I can do that exact same thing for this input field that I have tried to reference as the input template variable name. So I'll specify the selector as input, and then I'll specify the read property as view container ref, and then whatever I get inside this input field as vcref would be of type view container ref. So if I log this to the console and save, I'll see that the input field as vcref is now also showing me the value as a view container ref. Now one last thing is a way to read an element as a template ref. You can do that by using the view child again. So I'm trying to read this ng template tag here. Now you have to remember one thing, that we can only read the ng template tag using template ref specified as the read property. So what I mean by that is, let's first try to log whatever we get inside the template ref onto the console. So let's do this, and I get template ref as this thing right here. This is a bit different from the view container ref because the view container ref has a lot of different things like element injector and stuff like that, but the template ref just has element ref. Again, we'll go in depth about the view container ref and the template ref in the video in the next section where we'll be creating a custom structural directive. So just bear with me till then. Now, I was also saying that we can only refer to a tag which has been specified as ng template using the read property as template ref. Why I said that was because if you try to, let's say, have access to the hello component using the template ref. So if I just change the name of this property as hello component via template ref, and here I specify the generic type to template ref as hello component, and if I try to log this to the console, then you'll see that it logs undefined. So again, you can only reference something and read it as a template ref if you're doing that for the ng template tag. But if you do that for any other thing, like by specifying the hello component in this case, then you will get undefined as the value. Alright, so now we have seen the different sorts of values that we can specify for the selector as well as for the read property. The other property that view child options accept is the static property, which is of type boolean. But this is again optional and is false by default. So if you don't specify static, then the value of static would be false, but you can specify true as well here. You'll specify true only if you want to deal with components or templates that are getting generated at runtime on the fly. So if that's not the case, you will not set the static property. But if that is the case, then you'll set the static property as true. And we will be seeing an example for this in a later section of this course when we will be dealing with dynamic component loading. Now, you might be wondering why we are using viewChild anyways. Why exactly is this useful? I mean, we now understand that we can have a reference to something that we have on the template inside our TypeScript class, but why exactly would we need a reference in the first place? So I'll be talking about a few use cases for which we would need these references for the templates inside our TypeScript class. So one of these is for component interaction. As you can clearly see, we already have a reference to the hello component that we have inside our template right here. As we already have access to the hello component, which is our child component, I can try to access the properties and the methods that are exposed inside the hello component. So in this case, the hello component right here has two public properties and methods, like the name property here and the log something method here. So let's say if I wanted to log something, then I could simply call log something from the parent component on the child component and be done with it. So here's that use case for logging the hello component, which I've done right here. This is what I'm trying to do when we access anything from the child component inside my parent component. The other use case is, let's say for example, if you have an input field inside your template, and if you wanted to add a focus to this input field once the page loaded, then you can do that using these reference variables that you have inside your TypeScript class. So let's say for example that I had this input field reference to this input field right here. Now with that, I can probably try to access the native element. If I type in input L, which would be of type HTML input element, then I can do something like this dot input field dot native element. So again, input field is something that I've read using this viewChild decorator, specifying the selector as input, which is this template variable name. And then I've specified the element type as an element ref. The element ref property has a child property named native element. Again, the native element here is the JavaScript object representation of this HTML input element that we have on the template. So I can assign it to input L. And once I do that, I can then simply call dot focus on it. As soon as I do that, you'll see that as soon as the page loads, there is a focus on that input field. If I zoom this in a bit, let me just try reloading so that it's a bit more clear. As soon as the application loads, you'll see that there is a focus on this input field. That wasn't really the case if I had not called this focus method on this input element. So if I go back here and let's try reloading the application, you won't see that focus. But there are times when you have a form in your application and you want to add a focus to one of those input fields on page load. So that is something that you can do with the viewChild decorator. You can also add some styles or CSS classes to elements on page load. So let's say for example, I already have the CSS class, which is an animation for blinking, and I wanted to add a blinking effect to this input field on page load. I can do that using this viewChild decorator. So at this place right here, I already have access to this input element, which is of type HTML input element. I can call class list on it, and then on the class list, I'll have an add method. So I can call this add method and pass it the CSS class that I wanted to attach on it. So I'll add this blinking class and save this. And as soon as I do that, you'll see that this field starts blinking on page load and it would stop blinking after some time. Alright, so this was all that I had to share regarding viewChild. Again, you can use viewChild in order to get reference to elements that you have in the view. And you can have reference using the selector. The selector can be supplied a few different things like a component name, a directive name, a template variable name, a service, or a template reference. And we have seen this in action using a component name, a template variable name, and template reference. You can also configure what needs to be read using this read property that we supply to the options. And then we use static as true only if we want to deal with dynamic component loading. And as I've already mentioned, we can only read element ref, view container ref, or template ref apart from the things that we get by default in Angular in case of a view child. And the property that we are decorating with the view child decorator can only be initialized inside ng after view init because that's when the view gets initialized. I've added a link to the documentation of the view child decorator right here, so please feel free to check that out at your own time. And the example that we had a look at, a link to that example is also shared inside this slide at the bottom left hand section of the screen. So please feel free to check that out as well. Now so far we were only trying to reference just one element, but what if we want to access a list of elements? Well, for that we use viewChildren, and that's exactly what I'll be talking about in the next video. So I'll see you all in the next one. So in the last video we discussed how we can use viewChild in order to get references to the elements that we have present on the view. But since viewChild can refer to only one such element that is present in the view at one time, we cannot really use it in order to reference multiple such elements that we might have present on the view. And so for that we use viewChildren. ViewChildren works almost similarly to the viewChild, but with the help of viewChildren we can have access to or refer to multiple elements that are present in the view. And now since viewChildren is going to refer to multiple elements in the view, it's definitely going to be a collection. So in order to store this collection, we declare that collection as a query list. And this query list is a generic type that can accept something. So the syntax of viewChildren looks something like this, wherein we use the viewChildren decorator that I've imported from Angular core. And then as you can see from the declaration, it's almost similar to viewChild. The only thing that you won't see here is the static property that you saw on the viewChild. But apart from that, almost everything is essentially the same. One small change that you'll see here is that now we specify the type of the property name as a query list of certain type. Now this type again can be whatever we get by default from the viewChildren decorator or something that we might have specified in order to read, like the element ref, the view container ref, or the template ref. So as we did in the previous example, let's start by specifying the selector and see what we get. So I've created a very simple StackBlitz example. Here we have a child component with the selector hello that just accepts an input property name and then interpolates that name inside an h1 tag. And then there's a parent component, that's the app component, inside which I have a name property, the value of which is Angular, and then there is an array with 7 items and all of them are empty at the moment. Now I've just defined an inline template over here and I'm iterating through this array which will have 7 items, and then I'm taking one item at a time, and with the help of using the ng for structural directive that we have already seen now, I'm passing the name property along with this I. The I here is the index that I can also declare on the fly by reading the index from this ng for structural directive, and I'm initializing it with 4. So that's why on the UI you'll see the hello component being printed 7 times along with different versions of Angular that we have seen. Another thing that you'll see here is that each of these hello components have been given a template variable named hello component. Now let's see how we can read all of these hello components using the viewChildren decorator. So let's start with the first one, wherein I'll be specifying a selector. Now the selector will either be a hello component or the template variable that I have created right here, this one. And I'm not really specifying any read property as such because it's anyways optional. Now the way I use the viewChildren decorator is that first I'll import it from Angular core the way I've done here. I'll also be importing the query list from Angular core because that's exactly what I'll be specifying as the type of whatever I get from the view children decorator. So this is the property, and the type of this property is a query list of type hello component. And as I mentioned, since this works exactly the way view child works, by default we will be getting the hello component. So in both these cases, in one of them I'm specifying the hello component as the selector, and in the other case I'm specifying the hello component template variable that I've specified over here as the selector. And in both these cases I'll be getting a query list of type hello component. Now, similar to the previous example where I tried to first access this property inside the ng on init lifecycle hook method, it won't work in this case as well, because it again would only be available once the view has been initialized, and the view would be initialized only once the ng after view init lifecycle hook method gets called. And that's why I've implemented the after view init lifecycle hook so that I could then call the ng after view init lifecycle hook method. So let me just try to console what we get from these two properties. I've just tried to log the hello component and the hello component via template variable to the console. So in both these cases, I'll get a query list. You can think of the query list as some sort of a wrapper on a regular JavaScript array. So it has a few things like changes, first, last, but then it also has something called results. Apart from that, it has other methods that you might be familiar with in case of an array, like map, for each, stuff like that. There's also this toArray method that can convert this query list into an array. Alright, so in both these cases, I get a query list of the exact same values. The first element here is again a hello component with the name property set to Angular 4. And the last component is the hello component again with the name property set to Angular 10, which is the exact same case in this example as well. So now we have seen the selector property being used in order to get access to the view elements using the view children decorator. But like in case of the view child decorator, we can also pass an optional options object to the view children decorator, and we can specify the read property as an element ref, a view container ref, or a template ref. So let's try doing that. I'll first try to read the element ref. I've created two properties here. One of them is hello component as element refs, and the other property is hello components via template variable as element refs. Now in both these cases, I'm using the view children decorator, but apart from passing in the selector one time as the hello component and the other time as a template variable, I'm specifying the read property as element ref. And then since I'm specifying the read property as element ref, I can also specify the query list as of type element ref. And with that, let's try to log what we get in the console in this specific case. So I'll just uncomment this out and let's comment this selector one, save, go back to the application, and we'll see that the first and last elements as well as the results are now of type element ref. In the previous example, we saw that these are of type hello component, but now they are of type element refs because we have specified the type to be read as element ref. Similarly, we can also specify these types as view container refs. So I've declared these two properties now with the read property set to the view container refs, and let's try to log these to the console. So just in order to save some time, I've already typed this code, and as you can see here, the result in this case is view container refs as the first and the last property, as well as every single property that we have inside the results array. And same is the case with this. Apart from that, we can also read these things as template refs. But like I said, in case of the view child, you can only refer to an element as a template ref if you're trying to read the ng template tag from your view. But here, we are trying to read the hello component or the hello component via the template variable. So in both these cases, again, ideally, I would be getting undefined. Just like we got in the last example when we tried to do the exact same thing for the hello component, but with the template ref. So I'll save this, go back to the application, and I'll now see that the first item as well as the last item as well as the results in both these cases are undefined. These can be defined
only and only if I specify an ng template tag, and then let's try to iterate over this exact same array and also give this a template variable. Let's say template ref. And now if I try to read this, and then let's log this to the console and save. If I go back to the application now, you'll see that in this specific case, we are getting an instance of template ref both as the first, the last, as well as every item inside the results array. Alright, so now that we have seen reading multiple elements and referring to them from the view inside our TypeScript class using the viewChildren decorator, let's look at a specific use case in which we can use the viewChildren decorator. So let's say, for example, I had a CSS class in here which was bg, wherein I would set the color property as red. If I wanted to apply this bg class to each and every item in this list at runtime, how would I do that? So I could use the viewChildren decorator in this case in order to reference each and every item that I have in this list, and then I would read it as an element ref, which is exactly what I've done right here. So I can now have access to all the elements that we have inside this list as element ref. What I can do with that is I can just call for each method on it, and for each item in this list I'll get the hello component, but I'll get it as an element ref. And now with this, I can specify the hello element, which is of type HTML element, as hello component.native element. And now that I have the hello element, I can just try to access the class list on it and then add a class. The class that I'm going to add is bg, which I've specified right here. Let's save these changes and see if the color of each item turns to red. And as you can see here, the color of each item in here turns to red. Now this is just one example. You might have a case wherein your requirement is to highlight a specific item or multiple specified items from this list. So you can do something similar here wherein you can create a CSS class for that highlight animation and then try to add that CSS class to specific items in the list. And that way you can implement your solution according to the requirement. So again, in this video we have seen the viewChildren decorator, which is almost similar to the viewChild decorator, but it is just for multiple references. Just like the viewChild decorator, it also has a selector to which you can specify different things like a component, a directive, a template variable name, a service, or a template ref. And in this example, we have seen how we can specify a component, a template variable name, or a template ref in here. And we have also seen how we can specify the read property as an element ref, a view container ref, or a template ref. Now so far in this video and the video prior to this, we have seen how we can get references to the elements that we have in the view. But what if we want to have access to the projected content? Well, that's something that you cannot really have access to using the viewChild or the viewChildren decorators, but you can use the content child decorator instead in order to have access to it. And that's exactly what we are going to have a look at next. So I'll see you all in the next one. Okay, so I ended the last video on the note that what if we wanted to have access to the projected content as well. Now let's try to understand the problem with the help of this example wherein I have three components: the app component, the hello component, and the projected component. I have used the hello component, and then the hello component has this ng content tag. So this can act as a host for any projected content. The projected content here again means this. So whatever markup that I pass in between the opening and the closing tag of the hello component. So there's this projected content component that I'm passing in as the projected content. This component has a plain old paragraph tag which says this is the projected content. And inside the hello component, apart from the h1 tag that is rendering the name property in an h1 tag and rendering some projected content with the help of the ng content tag. And this is how it looks like so far. So again, inside our app component, I'm using the hello component and then I'm projecting some content where I have placed two projected component and then an input, and that's exactly what we see on the UI along with the actual content of the hello component, which is this hello angular. Now let's say that I wanted to have access to the projected content inside the hello component. Now we already know that if we have something in the view of a component, then we can have access to it using the view child decorator. So that's exactly what I'm trying to do here. I'm using the view child decorator here, and we are already used to using the view child decorator now. In first case, I'm using it just with the component name. In the second case, I'm using it with a template variable name. And in the third case as well, I'm using it with a template variable name. But this time around, I'm reading the element ref from the view child. And as we are used to doing, I'm trying to log whatever we get in these properties inside the ng after view init. And let me just specify that this is the content that's coming in from the ng after view init lifecycle hook method of the hello component. So I'll save this and let's see what we see on the screen. So I can see the logs to the hello component and the ng after view init, but here I'm seeing undefined for some reason. Now again, the content that I'm trying to read here is this projected content that would ideally be hosted inside the ng content tag, which is coming in from the template of the parent component, this one. And this is the projected content that I'm trying to read here. The first one is just by using the projected content component type. The second one via the projected template variable name, which is this. And the third one as well via the input template variable name, which is this. So this is the problem that we are facing right now, that we are trying to access the projected content with the help of the view child decorator that we are used to using, but we are not really able to have access to that projected content using the view child decorator. And that's where the content child decorator comes into the picture. Now the content child decorator works exactly the way the view child works, but it's just for the projected content. It again has a similar syntax. So we have the decorator, it has a selector, and then it has a read property and the static property, just the way the view child decorator does. And now the only difference here is that instead of reading these specific properties that we get by the content child inside the ng after view init, I try to read it inside the ng after content init. And we have already seen that the ng after content init lifecycle hook method gets called before the ng after view init lifecycle hook method. So if we even try to access this inside the ng after view init lifecycle hook method, we should still be able to have access to these properties. So let's quickly have a look at how we can change the current implementation in order to actually get those values. So in order to have access to that projected content, instead of using the view child decorator here, I will be using the content child decorator. And let's see if we see something onto the console getting printed. And as we can already see, we have the projected content now. But again, you can have access to this projected content if you're reading it via the content child decorator sooner. And instead of trying to access it inside the ng after view init lifecycle hook method, you can try to access it inside ng after content init lifecycle hook method. And then I'll also have to change the implementation here. So instead of implementing the after view init lifecycle hook method, I'll be implementing the after content init lifecycle hook. And then if I save this, I should still be able to have access to these different properties. Now again, as I've already said, that all these properties that we try to read through the content child works exactly as the same way as we are used to using it in case of the view child. So I can do the exact same things here as well. So let's say, for example, if I wanted to read just this input as a view container ref, I can do that. And let me just rename this to as view container ref. And similarly, if I want to read something as template ref, I'll have to specify the ng template tag here as the projected content. And then with that, I should be also able to read this as a template ref. And in the read property as well, I'll be specifying template ref. So template ref here. And that's something that I import from Angular core. And then the template ref is of type something, so I'll just specify HTML element here. And let's also change the name of this variable to as template ref. Now let's try logging in these two specific fields in the ng after content init. So let's try logging both of these to the console and save. And if I go back here, I'll be able to read that as a template ref and as a view container ref. And again, if you talk about the use case, I can do the exact same things that I am used to doing with the view child decorator, but this time for the projected content. So say for example, if I wanted to add a focus on this input element when the page loads, then I could do something like native element dot focus. And if I save this, I will be able to see a focus in here. And then similar to the content child decorator, I can also use the content children decorator in order to access multiple elements which are projected into the view of my component. And similar to the view children decorator, this also is going to then be of type query list. So let's quickly check this example as well. So again, we have the exact same components here, the app component, the hello component, and the projected component. The projected component is still the same, wherein it has a property, a method, and then there's a very simple p tag inside the template. If I talk about the app component, this time around, I'm just using an ng for structural directive in order to loop through two arrays that I have. So one of them is the via component and the other one is via template variable. If I go to the component, I have these two via component and via template variable arrays. Both of them are arrays of size 5 and 6 respectively. And so I'm iterating through them, and then that's what is generating this projected content inside the app component. The app component again is inside the hello component, and the hello component again is a very simple component with an h1 tag here that's interpolating the name. And then there is this ng content tag that is hosting the projected content. Here as well, I have access to the projected content using just the component type as well as using this projected template variable name that I have specified inside the app components template right here. And then there's also one input tag here that I'm trying to access by using the input template variable name. And then I'm trying to read the element ref of it. Now I'll be accessing all these things right inside the ng after content init lifecycle hook method. And here's an example of trying to read the property or call a method from the first item that we have inside the projected components. And so this is what I'm seeing onto the console. Now you'll also notice that since the type of all these components is projected component, so if I try to read the projected component using the content children decorator, then I'll get the length as 11. But if I just try to read the components using the projected template variable name, which is coming in from this via template variable, the length of which is 6, then I will be seeing only 6 items in this list. And then again, since there is just one input that we have with the input template variable name inside the projected content, if I try to read that using the content children decorator, I will see a query list, but it would just have one element ref. And the type of this again should be query list of element ref. And similarly, we can do the exact same things here as well. Like say for example, if I just wanted to add a highlight here on this text field as soon as the page loaded, and let's say that I already have some styles in place, so let me just paste in those styles. Now these are the similar styles that we have already seen in one of the past videos, wherein there is this blinking class that I'm trying to attach to an input field, and then that gives that input field some sort of a blinking effect. So if I try to add that blinking effect to the inputs that we get from here, I can do that using this property that I've tried to access. So this would be this dot input via template variable dot. Now since this is a query list, it would have quite a lot of things like the first, last, and stuff like that, but we already know that there's just one element ref in this query list, so I can just use the first property, and then on that first property I can try to access the native element. Once I have that native element, let's also assign it to a local variable called input L, and this is again going to be of type HTML input element. And with this element I can then try to access the class list and try to call the add method and add the blinking CSS class that I've specified over here. and see if we get the blinking effect on the input. And I don't see any blinking effect. Let's try to inspect this and see if it has the blinking class. So I can see the blinking class being applied to this input, but I cannot really see that blinking effect. Let's try reloading the application to see if that works. Nope, I still don't see the blinking effect. Well, what exactly could be the reason for this? The reason is because of view encapsulation. Remember the three different types of view encapsulation that we talked about? One of them was emulated, the other one was shadow DOM, and the third one was none. And by default, the view encapsulation is set to emulated. And what this means is that our component is going to have access to the global CSS classes, but our CSS classes that are local to a component won't be accessible outside. Now the projected content that we have lives inside the app component right here, and our CSS class is inside the hello component. So our CSS class here is local and would be encapsulated only to the hello component. So it won't be accessible outside the hello component, that is inside the app component. And so there are two things that can be done about this. The first thing is that you can add these CSS classes that we are trying to apply to the styles CSS. So let's try doing that first. So I'll just add the blinking class and the animation to the styles.css because that's the global style. Let's add that here and save. If I go back, I see the blinking animation happening on the field. So that is one way of going about this. But then again, I also have a capability to set the view encapsulation on the hello component, and I can set it to none. And with that, I will have access to all the global CSS styles, but my style would also be accessible outside my component's boundary. And so let's try doing that. I'll comment the global styles out, and let's see here that we are not really getting that blinking effect. But if I try to go back to the hello component where I already have these CSS classes, I can set the encapsulation property and then set it to view encapsulation dot none. And as soon as I set that and save, you will see that the CSS class is getting applied. Right? So in this video, we saw how we can have access to the projected content using the content child decorator. And if we want to have access to multiple such elements at once, we can use the content child decorator instead. And that brings us to the end of this video. In the next video, I'll be talking about Angular's change detection mechanism. So I'll see you all in the next one.
Hello guys and welcome back. So in this section we'll talk about change detection mechanism in Angular. Now, change detection is a process of capturing the internal states of an application and then somehow projecting these changes to the user. Okay, in simple terms, you can say that it's basically a way of synchronizing your model with the view. Okay, now if you come from an AngularJS background, you'd already know that change detection in AngularJS is generally triggered when there is an asynchronous task. Okay, now by asynchronous task, I mean these three types of tasks. They can be DOM events, they can be XML HTTP requests, or they can be the timer functions like the set timeout or the set interval. Okay, now Angular uses the concept of zones that was inherited from a language called Dart, and Angular comes up with its own zone named ng zone, where and everything that we code is generally run inside a zone. Okay, so every component has its own change detector, and we can have access to that change detector by injecting a dependency known as the change detector ref. Okay, now how exactly does this zone work? So what happens is that a zone is forked, okay, and then the run method on that forked zone is called, and whatever function or whatever asynchronous task or code that we are writing would be run inside that particular zone. Okay, so here is one of the examples of that. So whenever there is a set timeout function call, that would be run inside a zone. Okay. Some of the other examples of such a zone aware say function are these, like so, where we are doing something like making the functions like add event listener or remove event listener or a promise or a set timeout zone aware. Okay, so we are making these functions right here, and then we are assigning those functions to the actual functions that are going to be called whenever an asynchronous task is run. Okay, so this is the whole process of monkey patching that whole asynchronous task handlers by the zone aware asynchronous task handlers. Okay, so whenever there is an asynchronous task now, Angular will be able to know about it because it would run in a zone, and then it has some flags like in the zone flag that you can see right here, in which way Angular will be able to know that a particular function is running. Okay. Now, zones can be created, they can be forked, or they can be extended as well. And it contains some functions like on zone created, which would be run whenever whenever zone is forked. It has functions like before task, which would run before a particular function is executed inside the zone dot run function that we have seen here. Okay, then we have the after task that runs whenever a particular function is completed running in that zone. And finally we have the on error function that gets called if the function that is running inside the zone.run function throws an error. Okay, but we can also extend a zone to add or include our own methods, and that's what Angular has done. Okay, so Angular has forked the zone and it has extended the zone API to add its own functions like on unstable, on microempty, on stable, and on error. Okay, so on unstable will notify us whenever a zone is entered or whenever some code is entering the Angular zone. On micro task empty would notify us whenever there are no tasks pending or there are no asynchronous tasks that are pending in the queue. OnStable will notify us whenever the last task in the onMicroTask empty has run. And finally, onError will notify us whenever there is an error. Okay, now ngZone is something that can be imported from Angular core. And if you want to run a function outside the Angular zone, then you can run that inside this run outside Angular function. Okay, and if you want to re-enter the Angular zone, then you can invoke it by invoking the ngZone.run method. Okay, now here's what happens during the, I mean, here's how the whole thing works. Okay, so since Angular is running all the code that you have written inside its own zone, it will know whenever the on micro task event is fired. Okay, and whenever that is fired, Angular will execute a function named tick that will eventually start the change detection mechanism. Now, every component that we have in Angular has its own change detector reference that you can have an access to using the change detector ref dependency that can be injected inside your component. Okay, and then you can also change the change detection strategy. By default, it's default. There are two types of change detection strategies: default and on push. Default will do change detection whenever, or it will, let's say it will detect changes each and every time, but on push will detect changes only when the reference of the input property has changed. Okay, so let's see what I mean by that. Okay, Let me just get rid of all this code here. All right, so now let's say that I have a parent component and I have a child component, and then let's say that I'm passing some value, let's say a user, which is an object that has a name property which is of type string. Okay, and let me just name this as say Jacob. Okay. Uh, Now let's say that I want to create an input property inside this child component. So to create an input property, I'll decorate a property, let's say user, with the input decorator, and this would again be of type object with a key named name, which is of type string. Okay. Now let's say I want to use this child property, or I want to use this child component. So I'll do something like app hyphen child to use its selector. And now I know that it has a property, an input property named user that I can assign to in here. So I'll do that like so. Okay. And let's just save this as of now, and since we'll be receiving the user property here, I can simply print that out onto the view or the template of that child component by doing something like this. I'm using string interpolation syntax here. Okay. Now if I go to my application here, let's just clear this off, and I'll get rid of this notification and reload this. I'm getting an error. Let's see what's the issue here. Let me just go back to the code and see what's happening. Okay, looks like I didn't save the file here, so I'll just save it and let's go back. Okay, so now Jacob got printed to the screen, right? Now, let's say I have these two buttons here. Okay, and with the first button's click, I'll change the property. With the second button, I'll just simply change the object. Okay, so I'll bind to the click event of it, and I'll call change property method here, and on the click of this, I'll call the change object method here. Okay, now I need to define these methods in my parent class. So change property and change object. Okay, in the change property method, I'll just change the property of the user method, the name property of it. I'll name it to, I'll change the name to Sam, and then in this I'll simply change the object itself. So I'll create a new object with a name property of say Tom. Okay, and let's just save this, go back to the application, and let's click on the change property here. Now the change property button should rename this to Sam, that it did, and the change object should change the name here to Tom, that it did. Okay, now this is by default that's happening. Okay, uh, so by default, if we haven't specified any change detection strategy, it is set to default. Okay, this is the default. It means that the change detection mode will be initially set to check always. Okay, um, now it was default anyways, so if I save this now, this wouldn't change the behavior. If I click on change property, it will change the name, and if I click on change object, then it will also change the name. Okay, but let's say I wanted to have the change detection only when the actual object was changed. Okay, so in this case, okay, so in that for that, what I can do is change the change detection strategy from default to on push, and let's save this now. Okay, and now if I click on the change property button, nothing is happening to the name here. Okay, but if I click on the change object, it changed from Jacob to Tom. Okay, now setting it to on default, or sorry, on push, generally saves you a lot of time, and it generally improves the performance of your application. So it is advisable that whenever we are trying to tune up the speed and performance of our application, we should definitely check this out and use on push. But then for on push, we'll have to use some other libraries like immutable.js that will always create a new instance of an object whenever a particular field inside that object has changed. Okay, so anyway, this was the different ways in which change detection can be the change detection strategy can be changed. Okay, so now let's also quickly see what is the use of the change detector ref. Okay, so suppose there is a use case wherein there isn't any asynchronous task, or if there isn't any particular say DOM event that is actually changing the data, but the data is still getting changed. Okay, so in that case you'll have to manually run the change detection. Okay, so to do that, what you can do is you can inject the change detector ref as a dependency into the component in which you want to detect changes, and then you can call the detect changes method uh, on that injected dependency, and that way you can detect changes even if there isn't any asynchronous task going on, but you still want to detect changes. Okay, I cannot really think of any particular example right now for this, but there might be a use case wherein you might require this. So just for the sake of knowing it, I'm telling this to you. So you can import change detector ref from Angular core and inject it as a dependency. What I mean by that is in the constructor, you can do something like this. This would be of type change detector ref. Okay, and change detector ref is something I've imported from Angular core. Now in the ng on init say, if there is a change or if inside some other function there is a change and you want to manually run change detection, then you can do something like cdref dot detect changes. Okay, and this will run the change detection cycle for you. Okay, so that's where it can be used. Apart from that, um, there's just one last thing called the change detection tree. So as you can see in this example, change detection works from the top level to the bottom. Okay, as you can see from the arrows here. So say if this particular node or this particular component in this component tree right here changed, it will select this particular path until the root of this component to be checked, and then when change detection is performed, it will start from the root component and then it will trigger down to this particular path. Okay, and this is generally the case when you have set the change detection strategy to on push. Okay, all right, so this was it regarding change detection. Now, in the next sections, we'll talk about some other building blocks of Angular, like say a directive or a service or any other building block of that sort. Okay, so I'll see you in the next video. Thanks a lot.